Hello grade 12s, welcome to my channel and let us revise for physical science term 1 exams. So I'm going to use this paper from the Eastern Cape from Chris Hani West. Okay, right, so instructions folks, very important. They are the starting point to any form of examination. Please read all of them carefully. I will just highlight the big three. Okay, issue of rounding off, minimum of 2 decimal places. This means no less than 2 decimal places is acceptable. And of course, when given an opportunity to explain something, we should be as brief as possible, but we can actually apply anything that essentially is part and parcel of what would be our argument. Now we know MCQs, folks, and the most important is that there's only one correct answer. And essentially, folks, if you find more than one answer, just know there's a very good chance the other answers have some flaws in them, or if at all they are all equally correct, just follow the instruction and choose just one answer. All right, so 1.1 says several forces, okay, are acting on a moving object. Okay, good. Which one of the following statements is correct when the object moves with constant velocity? Now, obviously, if the object is moving with constant velocity, it means the resultant force is 0. And this simply means there is no acceleration. And if this is the case, we always say the forces are in equilibrium. Right? So the forces acting on the object are not in equilibrium. That's already wrong. The object has a non-zero. Remember, it is 0. Resultant force acting on it. The object has a non-zero acceleration. Again, that's nonsense because the acceleration is 0. The forces acting on the object are in equilibrium. So that's good. Okay, pretty straightforward. But do make sure that you are sure the answer you are selecting is not a mistake. Now, which one of the following quantities? Remember, in physics, we've got two types. We've got vector quantities and scalar quantities. So which one are we talking about? Okay, which one of the following quantities is the tendency of an object to resist change in its state of motion? That's inertia. So this is straightforward Newton's first law of motion. So it's either you know or you don't. 1.3 reads, a ball is thrown vertically upwards. If we are throwing it, it means we are giving it initial velocity. So there's a chance this is a projectile. But let's read on. Which one of the following graphs best represents the resultant force, okay, exerted on the ball against time while the ball is in the air? And of course, this statement was a very much needed statement. If we ignore the effects of air resistance, it means the resultant force acting on the ball is going to be the gravitational force. And we know that this is a constant for any given object. Right, so this graph says, well, we're going up and we're going down in a parabolic fashion. This is not possible. We don't really change direction. Same idea here. We don't really change direction here. And of course, let's see. This one also suggests that there's a change in direction of our force in a way. And it tells us that it also changes. This one says it increases and then drops. This one says it drops and then increases. This is absolute nonsense. Definitely it is a constant because it never changes for every object in question. Right, so these are very easy. Now, a ball moving horizontally at a constant momentum, P. Now we know that if momentum does not change, this object is moving at constant velocity and kinetic energy K. Now the ball collides with a wall. If there's a collision, there's going to be an impulse moment, isn't it? Yebo. And bounces back horizontally. Can you see there has been a change in the momentum of this object because it has changed direction. Immediately after the collision, the ball has a kinetic energy of 1/9 of K. Okay, you can see that it has decreased. Now the mass of the ball remains constant, which is usually the case. Now which one of the following is the momentum of the ball immediately after collision? Right. So this already tells us, folks, we need to find the velocity of the ball after collision. That's the only way we can do this. Now, folks, this one is one of those questions where you can't just pick an answer. Yes, you can be lucky and guess it, but it's not so easy. First of all, we know that momentum P is equal to mass times velocity. This is very important. Now, we want to know what would be the velocity after collision. But now this question is a bit crazy because we see only P in here. So this is in relation to the original momentum. Now let's find out what is going on. We were told that, of course, if we make velocity the subject, we know that V is going to be P over M, right? So that's something we can keep in mind. Secondly, we take the scenario of the first instance. We want to know what K is. We know that half mv squared is equal to K, right? And if we handle this business nicely, we would see that essentially we want to define K in terms of P, right? So we're going to say this is a half of M. Now instead of V, we're going to put P over M, all squared equals K. Now you can see that this is going to be just a half M into P squared over M squared equals K. And the square takes the M, and all we have left is that K equals, numerators multiply is going to be 2 squared over, P squared over 2M. So this is K in terms of momentum and the mass of the object. Right, so as you can see, guys, this question, you can't just spend 2 minutes on it. Okay, maybe you can, but you sometimes have to really think a bit deeper than just, going through the motions. Now let's have a look at the second scenario. We know that half mv squared is equal to 1 over 9k. This is the second instance. Now, folks, we're interested in knowing the velocity. So, obviously, what we are going to do, we will essentially say this is half mv squared equals, now this is 1 over 9k. What did we say was k? It's p squared over 2m, right? Right. And then what are we going to do about it? Well, we want to know the velocity. That's the most important thing. So let's see. Let's see what happens. So this is going to be, okay, let's just first take it easy. Mv squared equals, this is just going to be p squared divided by 18m. Okay, now we move on to the other side. Okay, that's a bit too much. Now we cross multiply, So we know that mv squared is going to be 2p squared over 18m. Right. And then what are we going to do about it? Well, we isolate v squared. It's going to be 2p squared all divided by 18m squared, right? And we can see that this goes once, goes 9 times. That's it. Then we go on. So as we continue, we know that the velocity is going to be the square root of p squared over 9m squared. Now this means v is going to be just p over 3m. Okay, so then we know that the momentum p, or let's just say mv in this case, we know that mv is going to be the mass into p over 3m. Now the mass takes the other one out, so this means our mv is going to be essentially 1/3 of p if we look at it. So this is good. So this means our answer must be B. Here there's no guessing, guys. As you can see, it's not that simple. Okay, it's not that simple. I'm thinking, was it possible here though to just solve for mv instead? Could it be possible? Let's just think about this stage, because I am kind of feeling working out velocity first would not have been a problem if we knew what to do. So let's just say this was mv squared equals 2p squared over 18m. Now we want to isolate mv. This is going to be basically 2p squared over 18mv, right? Now let's see what happens. mv is, this is basically 1 over 9, right? So this is p squared over 9m. Instead of v, we're gonna write p over m, as we saw from this equation. Because I'm feeling like we went too far. Let's see, this means mv, that's momentum, isn't it? Is going to be equal to, obviously the m's take each other out. So this is just going to be p squared over 9p. Oops. Alright, so this one is not giving us the thing. So this tells us that this is 1/9 of p. Okay, it doesn't really give us what we want per se. Okay, so sometimes you just check a few things and be sure if it doesn't work. Of course, if you see that the answer you get is not part of these answers provided, then it's already giving the idea that perhaps the approach is incorrect. Okay, so we are fine with B for 1.4. Now the compound C5H10O2 can be, now remember, this is the general formula CnH2nO2, essentially. So if we see 2 oxygens, there's 2 possibilities. It's either we've got a carboxylic acid, right? Because of the COOH, can you see there's 2 oxygens in there? Or we've got an ester. It's possible. Right. An ester has the C double bond O and then the OH. No, you're lying. Like this. Yeah. Stuff like that. So we can see there's 2 oxygens within the molecule. So essentially, we know that once we see this kind of a formula, we're looking at 2 things. And the good thing is, these are what we call functional isomers. Right, these are functional isomers. So there's a very good chance that we would be talking about this. Now it says this compound can be an alcohol. No, it can't be. Yes, a carboxylic acid or an ester. Right, so the answer is 2 and 3. So this is D. So again, a bit of understanding of how these functional groups work, or at least how these molecules work, is good. So consider the structural formula and IUPAC name of each compound is shown. Yeah, got propane, got ethanol, an aldehyde, we've got ethanol, and fluoroethane. So that's it. It says which one of these compounds has the highest vapor pressure at room temperature. Okay, normally in physics when we talk about this is 25 degrees Celsius, isn't it? Or 298 kelvins. Please know these things, guys. You're gonna get caught out if you don't. Right, which one has? Now you see, the good thing is that propane and ethanol have the same molar mass, right? These 2. They have the same molar mass because remember this is 12 by 3, which is 36. 7, 8, 9, 10, 11, 12. Huh? This is 36, right? Plus how many? 1, 2, 3, 4, 5, 6, 7, 8. So 36 plus 8 gives us 44. So this is 44 grams per mole. If we look here, this is 24, right? 24 plus 4, that's 28, plus 16, that gives us 44 as well. Yeah. So between those 2, which one would have the highest vapor pressure? Obviously it's the one with the weaker intermolecular forces, because it quickly evaporates, than one which has stronger. Remember, this one has London forces. We can call them weak London forces. And then here we've got a strong dipole. Of course, maybe let me not say strong, but perhaps stronger. Is it stronger? Okay, let's just say it has got dipole forces. Dipole forces plus weak London forces. So can you see it's got 2 types of forces? Definitely it's going to be stronger. This one has only London forces, right? So this one definitely has an additional strength compared to that one. So obviously between those 2, this is what we would have. But now let's compare these other ones. Now ethanol, let's see what would be the molar mass for that. So that's 24 plus 16. This would give us 40. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So this basically gives us 46 grams per mole. Molar mass. Now the only reason I'm focusing on the molar masses, guys, it's only because these are of different homologous series. Remember, we cannot compare apples and bananas fairly. Okay, it's not good. So in this case, as we could see, the first one was a bit of a fair comparison because the 2 molecules actually have something in common. But now let's look at these last 2. Now you see the problem with ethanol here compared to the first 2, it already has a higher molar mass. Okay, so that's not a good idea for this comparison, because by the mere fact that it has a higher molar mass, it means there's more electrons involved here in the London forces. Okay, so this already tells us that the strength of the London forces here is going to be bigger than the strength of the London forces of the other two. So already it's essentially out. Propane still works out. But again, with alcohols, we know that there's strong hydrogen bonds plus the weak London forces. But the problem is that, guys, the catch with this, if this molecule was smaller in terms of molar mass, it doesn't matter that it has strong hydrogen bonds. It may actually not have the same strength compared to a much stronger molecule which may not have hydrogen bonds. So this is why this kind of question, I feel, not quite good. Anyway, let's look at fluoroethane. Fluoroethane has dipole forces plus the London forces. Right. So what would be the molar mass of this? By the way, what's the molar mass of I hardly checked fluorine. Let's just go and have a look. Fluorine has 19 grams per mole. Okay, so this is 19 plus 24, right? This gives us 43 plus 5 hydrogens. So this gives us 48. Can you see that? 48 grams per mole. Now, if you think about it, can you see 48 grams per mole is somewhat bigger than ethanol? Ethanol's molar mass. Now, do you realize that if I can tell you which molecule of the two will have a higher boiling point, you would want to jump to ethanol because you see the hydrogen bonds. But if you look at the molar mass, they don't have the same molar mass. It's not even comparable. I mean, 46 to 48 is double 2 digits, or at least it's by 2 units, which is significant because it has to be at least less than 1 unit to 1 unit to accept the comparison. But in any case, we know that by the mere fact of its greater molar mass, it already tells us there's lots of electrons participating in the London forces, but there's also dipole forces here. So this molecule will have a stronger intermolecular force strength compared to ethanol, even though ethanol has hydrogen bonds. So in any case, which one remains the favorite? It's still going to be propane, mainly because that, compared to the others, it's definitely going to have a smaller molar mass. That means lesser electrons participating in, the London forces, themselves being weak forces compared to the rest. So essentially, I think the game of molar masses was more important here to know exactly who to choose. So in any case, the one that would have the highest vapor pressure, I would choose propane. But as you can see, it's not such a smooth decision to make. You have to really think outside the box. Anyway, guys, I'm happy that such questions sometimes do come so that you can see what to use, because you guys get fixated into the same style of questioning as it has been perhaps in the past 3-4 years or so, but you kind of turn a blind eye to dynamicity. Remember, these things are dynamic. We twist and turn in science. There's no yes, there's no in science. both of them exist. It depends on the situation at hand. Okay, right. Anyway, folks, I think the best answer would be propane, because obviously if we look at the molar mass, it has the smallest and the weakest of intermolecular forces compared to the others. So in essence, it should be the one that evaporates easily, or at least boils faster, and that means it converts into gas. So that means there would be more vapor pressure from that molecule than the others. Of course, seeing that they are much heavier than it, and they have stronger forces instead of the weak ones only. Right, folks, let's not talk too much about that. I just hope you understand the justification for my choice there. 1.7 says the addition of hydrogen to an alkene is called, obviously it's hydrogenation, right? It's either you know or you don't. Now, folks, that's it for the MCQs. So now let's get to some serious business. All right, so we've got question 2. Now, question 2 reads, a block of mass 3 kilograms. Okay, so this is the one. Connected with a light inextensible string that is hanging over a frictionless pulley. Now, what is the functionality of this inextensible? It is to tell us that the tension on either side of the string, essentially this one here, the tension here should be the same as the tension that side. Okay. First of all, because the string is inextensible, and it's light, it doesn't add weight into the system. And of course, the frictionless pulley also does the same job. Now, to another block of mass x, as shown in the diagram. So there's the block, it's hanging. The 3 kilogram block is placed on an inclined plane at an angle of 25 degrees to the horizontal. So that's good, and is pulled by a constant 35 Newton force along the incline. Remember what I was saying? It is being pulled, right? The block of mass x accelerates at okay, the mass of block x accelerates at 0.5 meters per second downward. So this means this force is not able to pull the system in that direction. So it means the direction of motion in this section is this way, and the direction of motion in this section is downward. So this means that force is not able to pull this object upward. As much as it is pulling in the opposite direction, it's actually failing. Now, folks, if we look at our plane, we will appreciate that it is smooth here. Nobody told us about it being rough, and so we can assume that there is no friction. But remember, you may at some point in the questions be introduced into some friction, but at this stage we're getting the impression that there is no friction. Okay, let's read on. The coefficient of oh my goodness, I spoke too soon, eh? Okay. The coefficient of kinetic friction between the 3 kilogram block and the surface is 0.2. So obviously then it means this is a rough surface. Okay. So sometimes, as you can see, the examiners can give a smooth surface in terms of notation, but then change their mind and add something. And of course, we're going to ignore the effect of air friction. So this is good. We don't have to worry about friction together with tension on the block X. Now it says define the term kinetic friction. So of course, guys, you should know what this is. Right. So kinetic friction is basically the force exerted between the surface and an object that opposes the motion of the object. Okay, So this is always experienced by a moving object. Right, so let's try and define this. Remember guys, in the exam you'll be surprised by things you are not prepared for sometimes. So understanding what these things are helps a lot in trying to make up a definition. You're not always going to cram these definitions because you don't know which one is going to be brought. Sometimes, last time you heard about kinetic friction was in grade 11. Now you are so used to other issues of grade 12, VPM and stuff, and now you've forgotten what that is in terms of a definition that you have read. Of course, you could revise all of these because remember, you know what is the scope of Term 1 exams. But at times to understand them is much better than to cram the definitions because you end up in trouble when a definition you least expected or perhaps you could not get to or you have forgotten. Very difficult to bring it out. So try to always make sure that in everything you describe, you put everything in it. For example, what is kinetic friction? We can say it is the force exerted between the surface and a moving object such that it opposes the motion of the object. Can you see guys, this description is not bad because it is a force, we know that, but it is exerted between the surface. Okay, who is exerting friction, by the way? Who? Is it the object on the surface or is it the surface on the object? Now the question is, who experiences friction? Is it the surface or is it the object or is it both? For me, if you are moving an object where there's friction, you will see that there's going to be scratching on the surface as well as on the object. So for me, I think it's best to say it's a force exerted between the surface and a moving object. Keyword is that this object has to be moving such that this force opposes the motion of the object. Okay, so I would assume that this is good enough, and of course you can go and have a look at a proposed memo, an official one for this paper, or you can go and double check the definition. At this stage I'm not really interested in giving it to you the way that you want. I'm interested in showing you how to survive questions even when things seem to be a surprise. Okay. 2.1.2 says, calculate the friction experienced by the 3 kilogram block. Okay, 3 marks. Well, what do we see, guys? We know that our 3 kilogram object has a force straight down, which is our friend Fg. But now in what direction is this object moving? Yes. It's moving down. And in fact, what would have been the direction of the components of the weight? The parallel component would be straight down, or at least downslope, not straight down, but downslope. So we know that this breaks up into its components, right? Yes. Which are themselves perpendicular to each other, and we know that the angle of inclination is the same as the angle between the perpendicular component, or should we say the vertical component of weight, and they are themselves perpendicular to each other. That would be Fg parallel, but in which direction? in the direction of our resultant, the FG. But now there's a friend here from the exactly opposite and equal in magnitude to that component of weight. That's the normal force. So since this object is not moving into the surface or off the surface, it means there is no acceleration in the perpendicular direction to that surface. So essentially the normal force is of the same magnitude. So the normal force is of the same magnitude as our FG perpendicular. So do you see, guys, we need to work. Why am I thinking about this? Because I know the frictional force is going to be mu k times the normal force. So we definitely needed the normal force. But the normal force here is equal to the vertical component of our weight, or the perpendicular component of the weight. Great. So we know, folks, that we can just write F K is mu k times the normal force. So this implies that our Fk is going to be, what was that? We're told that this is 0,2 E2. Now the normal force here is the same as that perpendicular component. It's mg. This is going to be 3 times 9,8 times cos 25 degrees. Therefore, our Fk is what we get. Let's say 0,2 into 3 times 9,8 times the cos of 25. Okay, so I get 5,332 decimal places newtons. Now the question said calculate the friction. Now the friction has a direction. It's going to be upslope. It opposes the motion. Remember, we needed to be sure and establish in which direction are these blocks moving. So this is going to be upslope. Or, if you like, you can think about it and say this frictional force is 25 degrees north of west. You can say that, 25 degrees north of west. Okay, or we can even decide to use the bearing method. The bearing method is because we know that this is 270 plus 25. So that's going to be 295, right? Yes. Or we can say this is at the direction 295 degrees. Or, if you will, you can use the complement of that 25 degrees and say that's going to be west of north. Okay. There's plenty of ways. Of course, guys, we can even say from the west we move 25 degrees north. So, as I said, these are some of the ways in which one can explain the direction. But to just say upslope is better and simpler. But do know how to do these others, because there's going to be a question sometimes say, please specify the direction using the bearing method, for example, and then you don't know how to do that. So I'm showing you these things so that you don't get caught. Okay, this calculation and the answer. But remember, for this answer to qualify for that full mark, we need the correct unit or the correct measure, correct SI unit, and the correct direction. Any one of the three not well represented, those marks get lost. So we've got 2.1.3. It says draw a labeled free body diagram indicating all the forces acting on the 3 kilogram block as it moves. Okay, that's fine. 5 marks. So this is not bad. So, of course, up the incline, we've got 2 forces that are acting parallel to each other. At this point, I don't care who's bigger and who's shorter. So this is going to be the applied force, right? Which is the 300 Newton force. And maybe we can say FA, you can just say F. I think F is good enough. And then this is going to be the kinetic friction, right? And then perpendicular to the component, to the surface, we expect normal force, capital letter N. And then there is going to be tension on the string in this direction. And there's going to be the weight straight down. At this point, I don't care who's big and who's small. So as you can see, we've got 5 forces, because we said we want this as it moves, but nobody told us where, which is very sad, because this block may end up, excuse me, it may end up floating, right? But anyway, let's leave that for later. So sometimes these questions need to be precise, folks. So we know what that label represents, and that label, and that label as well. So we don't have to explain them. And please try to use the familiar ones. If you become too creative, you may dig yourself a hole. But if you can handle it, do it. Now calculate X, the mass of the hanging block. Can you see? A complex calculation is somewhat easier. We were not told anything, hey? We weren't told. But in any case, the acceleration of the, what you call the block X, is the same as the acceleration of the 3 kilogram block. That's just the one thing we need to appreciate. So if we want the mass of that block, so we basically need to find the tension. But this is just 4 marks, I don't understand. We need to find the tension, right? Because once we find the tension, then we will be able, yes, we need to find the tension, and then we will be able to, I'm thinking now, how are we going to handle this business? Okay, not a big deal. There's going to be a force down, right? And what should that force be? It's going to be Fg, right? For that block. Now, Fg has to be greater than the tension for us to accelerate. Great. So, we can use that. Let me see. We know that we can use the 3 kilogram block to find the tension. Once we have our tension, we can now use, we will then be able to use, this question, I'm thinking about it now. Why am I hesitating? I am finding myself hesitating because there's quite a few things to consider here. Anyway, let's work out the tension first before we rush into problems. If we think about the 3 kilogram block, we've got 2 forces down. It's going to be the tension. I don't know which one is bigger and smaller. It's going to be the Fg parallel. Then there's 2 forces opposing that. It's the applied force and the frictional force. Okay, and we know that the acceleration is going to be the same because of our inextensible light string and that frictionless pulley. So we'll experience the same acceleration. So let's go for it. We know that the resultant force is equal to ma. Let's not even think about it too hard. If we are moving in this direction, it means the sum of the tension and Fg parallel. So the tension plus Fg parallel K minus the sum of the applied force plus the kinetic friction must give us ma. Now the tension we don't know, plus Fg parallel is going to be 3 into 9,8 into sine 25 degrees. Right. And then we subtract, that force was 35 newtons, plus, okay, the frictional force is going to be what we have above. So this is 5,33. So the examiner was a bit friendly as well. So this is 3 into 0,5. Of course, we are choosing the direction of motion as positive. Right. Now, folks, I can isolate the tension nicely. We know that our tension is going to be equal to 3 into 0,5 plus the sum of 35 plus 5,33 subtract 3 into 9,8 into the sine of 25 degrees. Nice and easy. Therefore, the tension is... Okay, so let's go for it. So 3 into 0,5 plus the sum of 35 plus 5,33. Then we subtract 3 into 9,8 into the sine of 25. Okay. If the answer is positive, I'm happy. So I'm getting 29,405 newtons. Of course, this is going to be down slope. Okay, so that is the tension. Now we want the mass of that block. Okay, so how will we find it? Well, we know that for object X, we've got two forces. One is its weight, and the other one is the tension. But the weight should be bigger than the tension because the object is accelerating downwards. Right. So we know now that then, again, we use the same principle. The resultant force must be equal to ma. So Fg, which is going to be minus the tension, is going to be ma. Fg is just going to be the mass of X. We can just say mx times 9,8 minus 29,405 equals X times 0,5. Okay, let's not say X, but M of X, or mx. So we've got 9,8 mx minus 29,405 equals, this is just 0,5 mx. Now, we have like terms. So 9,8 minus 0,5, 9,8 minus 0,5 gives us 9,3. So this is going to be 9,3 m of object x equals, we transpose this, it's going to be 29,405, right? Therefore, mx is going to be 29. Ne. Okay, let's just not rush. Right, let's see. So we've got 29,405 divided by 9,3. So this gives us a 3,16 kilograms. Nice and easy. Alright, so that's the mass of our object. Of course, guys, what matters here is the plan. Okay, as you can see, the examiners have a tendency to just pull your leg a bit, give you less marks, to make you think this question is easy, and only to find that it's not as easy as they're making it to look. Sometimes the mark allocation can be used to conceal a problem and let you sweat, sometimes hopelessly. Okay, guys, so what are we doing here? We know that the principle, we can mark it wherever you mark it, either way we did it or where we simplified it. It's not a big deal. This is a calculation, okay, on its own. The others were essentially given. I don't know, guys, why is this 4 marks? Anyway, we're going to leave it there and say perhaps substitutions here. I don't know, guys. And the marks. The rest was a means to an end, I suppose. Let's leave it at that. The examiners sometimes become ridiculous, and there's nothing you can do about it. Okay. Sometimes you may derive simultaneous equations in terms of the tension, and you will see that once you eliminate the tension, you will literally end up with the mass that we want. But however you do it, guys, it's up to you. No one will dictate that much on how you're going to do this. Okay, let's do 2.2 quickly. 2.2 says the moon, which has the mass 7,35 times 10 to the 22 kilograms, is 1,2 times 10 to the 5 kilometers away from the Earth, as shown in the diagram. Right, as you can see, this is surface to surface, right? But the moon must have some radius, isn't it? If we're going to calculate the force, we need the radius of the moon as well as the Earth. We know that the Earth has its radius r, which we need to know the value of from the constants. So don't be caught out. And of course, the mass of the Earth, we should know what it is. Now it says the gravitational force between the moon and the Earth is 1,91 times 10 to the 20 newtons. Now state Newton's law of universal gravitation in words. So as in the previous video, guys, don't be lazy. Do it. Don't say, I know this, I'm going to skip this question. Get into the habit of leaving nothing undone. So what do we know? We know that I can phrase it my way. It's not a problem. We can just say the gravitational force of attraction between any two particles in the universe is directly proportional to the product of the masses of the spheres and inversely proportional to the square of the distance between them. I mean, that's nice. Or you can go about every particle in the universe exerts a gravitational force of attraction to every other. But you know what? I don't have the time. I'm just going to go about it. The gravitational force of attraction between any two particles in the universe is directly proportional to the product of their masses and inversely proportional to the square to the square of the distance between them. If we said particles, we know that we'll assume that they're just spheres or points. Anyway, as I said, folks, it's very important to notice that this is a gravitational force and it's of attraction between any two particles in the universe. And of course, the proportionalities, folks, are very important. And if you forget, just remember Fg is big G m1 m2 over r squared. Describe this, you are done, but try to make sure the words you choose have some significance in maintaining the signs. Do not lose the signs. Otherwise, you don't have to say it as others do or any other writing. As long as you're describing the same phenomenon, we should be happy. Right, next question says, calculate the radius of the moon. We knew we were going to need to. Right. So this is very important. So let's go for it. We know that Fg is going to be big G m earth m moon divided by the distance between them squared. Now let's substitute. We've got 1,91 times 10 to the 20. It's quite a big force, yo. It's quite a big force. This is going to be equal to, the big G is 6,67 times 10 to the minus 11. Please know these constants by heart sometimes. It helps. I know this is 5,29 times 10 to the 24. Let's check it. You see, when you get a bit fuzzy here, it's 5,98, not 29. Can you see? Small, lovely mistakes. But make a habit of remembering this, please. So this is 5,98 times 10 to the 24. I missed it by a small anyana digit. Leave the mass of the moon. While we are still here, we just want to get stuff done. So our r squared is going to be the radius of the earth, which is 6,38 times 10 to the exponent 6. Then we're going to add the distance between these two. So we can now leave our business here. Please, guys, do not lose these marks. So we're going to take the distance between them and add it here as 1,2 times 10 to the exponent 5 plus the radius of the moon squared. Now, what was the mass of the moon? So they told us is 7,35 times 10 to the 22. Obviously, you may carelessly think the mass of the moon is bigger, but look at that 10 to the 22 compared to 10 to the 24, you see? So the mass of the earth is bigger. Do not be fooled by those decimals. Anyway, folks, this is what we are going to do. So, it is very important to be strategic here. So this implies, if we think about it, we are going to say, look, we move this guy there, and then we move that one down there, isn't it? Just cross multiplication. This makes life a lot easier than to, waste time calculating, and you know what? You don't want to do that to yourself. At the same time, you know that there's a square here. So we might as well take the square root. Okay, so if we move this thing there, we take the square root, then we're going to have this coming up as it is. But we're going to take the root of everything else. So all I'm going to say is that I don't have time to waste. I'm going to say the radius of the moon is going to be the square root of 6,67 times 10 to the minus 11 into 5,98 times 10 to the 24 into 7,3 times 10 to the 22. Maybe let's back it up a bit. All divided by our first 1,91 times 10 to the 20. And of course, guys, we're going to subtract from this whole thing the sum of these two, 6,38 times 10 to the 6 plus 1,2 times 10 to the 5. Unfortunately, the space was not so accommodating. The radius of the moon is what we will get. See, we avoid trouble, but be very careful. 6,67 times 10 to the minus 11 to 5,98 times 10 to the 24 into 7,35 times 10 to the 22. All divided by 1,91 times 10 to the 20. We can just do it, guys. We can just do it. We can say minus the sum of 6,38 times 10 to the 6 plus 1,2 times 10 to the 5. You see, we do it all in one go. And what we see here is a crazy number, but I'm going to make decimals. I'm going to say this is 3,85, writing it in scientific notation, times 10 to the exponent. How many did we push up? Pushed 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? Well, I'm not happy with it. I am not so happy with it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Anyway, now I'm really thinking, can this be? Is it possible? But anyway, if we think about it, I'm just comparing now. Can the radius of the moon be bigger than the radius of the earth? Now let's just see. If we subtract the radius of the earth from that of the moon, what do we see? Let's see, 6,38 times 10 to the 6. I just want to check something. Well, I'm getting a positive answer, so this means this is good. So this is meters. Anyway, I'm being thrown into the deep end by this I was trying to compare it with this guy. Sometimes always be on the alert. I'm trying to compare it with this guy. So that looks bigger, but if you look at the preceding decimals, they effectively tell us that no ways, it's small. But again, if you're not sure, you take this, you subtract that. If you get a positive answer, it means this is still bigger than that. And obviously the moon is smaller than the earth. So that should be correct. Of course, unless the question is a bad question, where the moon is presumed to be bigger. Some examiners can do it on purpose so that you end up sitting there and thinking too hard. If your gymnastics were correct, there is no need to sweat. Alright guys, so that's it for that question. So we walk away with our 20 marks without any silly questions, asked on that. Now let's get to VPM. Question 3 says, we did not mark. How many marks was this? 4 marks, of course. 1 mark for that. 1 mark for this guy at the bottom. That would be 3 marks, and then the general substitutions for 3, and the final answer. Okay, nice and easy. Now, question 3 reads, a helicopter picks up a package through a cord from the ground as shown below. The package is then pulled at constant velocity of 8 meters per second. So this is already saying that this package is not a projectile because the forces are in equilibrium. Now it says, will the package be considered a projectile? A hell no, with a big N and O. While being pulled up, yes or no? The answer is a definite no. Nee, my bro. Es nie projectile daso. Right, give a reason for your answer in 3.1. Okay, what are we going to say? We can just simply say the gravitational force here is not the only force acting on this object. Or we can say the resultant force is 0. So this is already telling us that we do not have a resultant force. And this cannot be a projectile. A projectile always has a resultant force. And the resultant force is the gravitational force. But I think it's best to just say the gravitational force is not the only force acting on the object. You can say the resultant force is 0. So you see, you just throw everything in there. But it's just 1 mark, Why do we know that this is the case? We know that if we draw a free body diagram, if you will, we will have the gravitational force. Then this is going to be the tension on there's going to be tension on the cord. And if this is doing constant velocity, it means those forces are equal. As I said, you can use anything to explain what's going on. You can draw this free body diagram to demonstrate what you're going to later say, that the gravitational force is not the only force acting. Nobody said you can't draw this. Remember, we're told if we have to explain something, we can use anything. So you can gooi alles. But of course, look at the mark allocation sometimes, or at least use other things to convince yourself rather than to try and over-convince. An examiner was already not trying to be interested in your whatever. Right, now let's have a look. When the package reaches a certain height h, the cord breaks, and the package undergoes free fall. Do you see, guys? I mean, bafethu kaneni kancane andiyiqondi le nto yena. Ngiyakhumbula into yoba ndinenzele iphepha lam lango-2005. Ndilenze ngo-2024 towards the end of the year. And this had something to do with this. And look, this question now is here. Of course, it's not exactly the same, but the same idea. For that one, it was a package or a container being lifted from a ship in some harbor. They said East London, right? And then the cord snapped while this was being lifted off. Similar story here, guys. Now, if you stuck with this channel and you made sure that everything presented here you are familiar with, and not just familiar, but you understand. Do you realize, folks, that those of you in the EC have had so many advantages? But it's not only you guys in the EC. I can tell you for free, if you look through all the other provinces, you will see some of the things I've shown you. If you look at the trial papers from Gauteng last year, the very same question paper from 2005 I told you about, when they asked questions on the quadratic equation, they asked about the rational root instead, because there was both a rational and an irrational root for a cubic expression, which was factorized into a linear and quadratic. The quadratic one was irrational. The linear one was the rational one. So you saw that those questions came. So if you guys don't pay attention, I promise you, you're always going to lose out. I always told people that I am a witch doctor. You know? Who is a doctor, by the way. So I'm both the witch doctor, if you will, if there's such a thing, and a Western doctor, if you will. Some people like to say traditional, but what is traditional? Because even the Western doctor is traditional, isn't it? To the Western tradition, he is traditional. So you cannot tell me that's a traditional. Just say witch doctor. Of course, it's not fair to say witch doctor. I don't know how to put it, though. You can say Gqawemveli. Oh, Thixo. Let's stick to witch doctor until we find a better word. So I'm both a witch doctor and a Western trained doctor, if you will. So I always have a hunch about things, guys, and all the things I've had hunches about have never surprised me because they always occurred. As I told you, for those who are stuck with this channel, I used to tell them that in my matric year, there was one time I was seated at home, just practicing as usual. Just took my, you see those orange, is it orange or purple? I don't know that color, but the study and masters of old. I took that and I just looked at a question that was deemed, beyond the level of higher grade even, on current electricity, which combined, the knowledge of Coulomb's law. Is it Coulomb's? No, Ampere law, where you're talking about parallel conductors and stuff, and electric circuits. And that married everything with Newton's laws of motion, because there's going to be some acceleration because of the magnetic fields. So essentially I did that, and I was like, come on, man, if I just opened my mind, because I never checked the answers, I got it straight up correct, but it took me a while to figure it out. But I didn't go into the solutions, and when I did, I realized that, okay, my solutions were more convincing than the ones you would see in the actual solutions presented. I don't know, for some reason I caught the idea that, look guys, I need to show this to my colleagues, because it involved two separate circuits, by the way, which had some sections or parts that were parallel. Hence, there was this issue of, parallel conductors and the magnetic fields. You know that when the currents are moving in the same direction, they attract. When they move in opposite directions, they repel. Or is it so? Yeah. Now, you put a conductor in there, or at least something that would have a current induced in it. So in which direction was it going to roll and things like that. But now the fact of the matter was that there were two circuits to consider. They were of the same EMF, so to speak. And now a lot of these calculations involved, trying to understand the EMF calculation and stuff. I showed these guys this question, and I even made a stride and went to my different teachers and manipulated them to borrow those books, because we were never given textbooks at the time. We only used those textbooks in class and would return them. But I was lucky my mother bought me that textbook in grade 11 already, so I had it with me throughout December grade 11, 2004. Then by the time I was doing my grade 12, I was mainly doing revision on most sections. I taught myself acids and bases at the level of grade 12. All those stoichiometric calculations, I'd already done all of them by myself, no teacher. Chemical equilibrium, I kind of didn't understand the part where you just do the table. I didn't know when do we cross over, because stoichiometrically from acids and bases, I thought we just cross anywhere. So I would cross even on the initial part and then end up getting confused. So for that one, I ended up not so sure what is going on. And then I quickly, at some point started to realize, no man, when this initial or at the beginning, you see zeros for the other one if nothing was mentioned. But if something is mentioned, then you see it. So, sometimes it takes a while to figure these things out. But then, I kind of went all the way to school, still not so sure. Yes, I was able to get some correct, some incorrect. Then the inorganic chemistry part, I also studied it before grade 12, including electrochemistry. So by the time I was in matric, guys, most of the time it was just revision. Even falling bodies, you guys call it VPM these days. We called it falling bodies. So, in fact, we even used the concept of terminal velocity there. So I had done all of those things, Newton's laws of motion, beforehand, okay? So pretty much my grade 12 was revision, I can tell you that. So I borrowed these guys, I borrowed for these guys this textbook, saying, guys, watch out, in the finals this thing might come. And I'm telling you folks, our electric circuits question had 2 circuits with the same EMF, the same idea. They failed it because they didn't think I was telling them something there. And most of the other questions I used to show them how to do, they showed up. Anyway, guys, all I'm trying to say, do not ignore the things I tell you. I know I'm a random person to you, but yay, I am not as random as you think. Of course, I have no connections whatsoever with the examiners or the examination departments of any of the provinces. I do not even have contact with any of the teachers in the schools, and especially those that set exams. So it's not because I know, it's because I feel it. And guys, if you watch my channel from 2021 when it started up to now, you will see that every time I preceded the certain changes you see in the exams in what I do in the channel, or at least in the manner that I do it. I'm not trying to say I'm special or anything, but I'm just saying, for those who have the privilege of seeing this channel before they write any of their major exams, do not think what you hear and see is for granted. Many have lived to see it. All the years from 2021 until now. Everything I presented before any major exam showed up in that exam. So be very careful. I'm not saying cram. All I'm saying, understand so that you can do. Anyway, guys, this sparked a long conversation that was rather parallel to this. Anyway, this is easy questions, as you can see, as coordinates. So right now, this thing, they say the motion of the package after the cord breaks until it hits the ground is represented through the velocity time graph below. Okay, now look at this, guys. We are not told to ignore the effects of air friction, which I have a problem if it is not mentioned. Because one thing for sure, we know that the acceleration is constant. And it's in one direction because the gradient is saying so. Can you see? It's a negative gradient. So this means the acceleration, obviously for a falling object like this, the acceleration is always downwards, okay? Because the chord is broken. So it always accelerates downwards. So this means down is negative. So the examiners have made a choice here. But now the question is, do we have a projectile or not? Definitely we do have a projectile, because for a projectile we've got a resultant force that is constant. And this is the gravitational force. Hence we're going to have a constant acceleration. If we did not, think about it. When the object is going up, there's forces acting on it. Right, there's forces acting on it, and these forces, one is going to be the gravitational force down, and the air resistance is also going to be down. Right? Now you can see that the gravitational force is great. So that means the acceleration would also be great, but this is against motion. So we would expect a steep gradient down in terms of a velocity time graph. Right? Right. Now this reaches maximum height. This is when it crosses there. But now when it changes direction, the gravitational force is still down, but the air resistance would be up. But by the fact that it's going down, it means air resistance is essentially less than the gravitational force. Now the resultant force would be the difference between the two. Now the difference between the two is definitely going to be less than when these two were added together. So this means, yes, it's going to be still down, but it's going to be much less. So you would expect something like that. Can you see? But we see a constant acceleration instead of an acceleration that changes the magnitude. So essentially, this tells us that air resistance is ignored. Well, it's not a matter of assumption, it's an investigation. As you can see what I'm talking about, there's a lot of things you can use to understand a scenario. So don't be fixated in being told everything. Sometimes check and see if you've got the things you're looking for. Between these two, there's only one that is constant, is Fg. Air resistance will change depending on how fast you're moving. If you're moving very fast, air resistance becomes stronger. If you're moving less, it becomes less. So that one is dependent on how fast an object is moving through the air. But Fg doesn't care. Okay, right. Anyway, let's get to the business, guys. We need to calculate. Right. What are we calculating? We are calculating the time t. So this is when it reaches maximum height. This is when the velocity is 0. Now if I may ask, what should be this velocity here? Well, remember it was moving at a constant velocity before it broke off. So that velocity should be the initial velocity. So that should be 8 meters per second. So those are some of the things that are important. And watch out. Do you see the time it took from the time the cord broke until it hits the ground is 8 seconds. That is there on the graph. We need to consider that as well. Anyway, folks, this is it. Let's just get to business. 3.3.1. We need the time t. This is easy. Why do I know it's easy? Because we know the gradient. 9,8, so it's going to be minus 9,8. It's the gravitational acceleration. So we can use either the area under the graph if we want. But now, what does the area under the graph represent, by the way? displacement. No, we don't know the displacement, so we can't. But we can use the gradient. Yeah, we can use the gradient. Change in y over change in x. That can help us. So let's see. We know that the gradient is going to be change in y over change in x. So the gradient is minus 9,8. It's the acceleration. Remember, the gradient on a velocity time graph is acceleration. So the change in y is 0 minus 8. Right? Because that's how everything is changed. Final minus initial. And then this is going to be basically t minus 0. So this implies that we have essentially a minus 9,8 equals minus 8 over t. Right? Right. So we cross multiply and do the things. We know that t is going to be minus 8 divided by minus 9,8. Therefore t is, where is my calculator? Minus 8 divided by minus 9,8. So this is 0,82 seconds. Nice and easy. Well, some other student may pursue the equations of motion, which is not a problem. Remember, when nobody tells you how you're going to do this, you just do it however you wish to do it. But make sure you know what's going on. So we can use our equations of motion that the final velocity equals the initial velocity plus gt. This is very easy. The final velocity, we see there is 0 at t, equals the initial is 8, plus we saw that acceleration downwards was negative, and we're looking for time. So this implies that we've got t as minus 8, we transpose and divide. Do you see how similar these are at the end? Because it doesn't matter which technique you used. At the end of the day, there's going to be some common step, right? So you can already see it's the same thing as when we used our gradient. So this should be 0,82 seconds. Okay, guys, so this is essentially as easy as A, B, C. Now, how do we get our marks? Well, in physics, guys, when we showcase some formula, whatever it is, we get our marks. When we show our substitutions, but mainly knowing the value of the gradient and the final answer with the correct SI unit. If this is the method you've done, that one. Okay. So here, perhaps the mark is for two things, knowing the velocity is 0 and that the acceleration is due to gravity. Either way, the marks are in the bag. So 3.3.2. We now have to find the magnitude of the velocity with which the package hits the ground. This is very easy. We know that the final velocity equals the initial velocity plus gt. Can you see how clean this thing is? Instead of this ugly and dirty subscript filled equations you guys have. By the way, you copied where it's not even necessary to copy them. But yeah, whatever. This one is going to be 8 plus minus 9,8. We saw that that is 8 seconds. Therefore, V is, let's see, 8 plus into minus 9,8 times 8. So this gives us the velocity to be 70,40. Remember, we're told 2 decimal places. You must add the 0 because the answer says 70,4. Add an extra digit. Otherwise, you lose a mark. Meters per second. At the same time, you do not present negative answers. The answer would have come up negative, but it just means downwards. But at this point, we are only interested in the magnitude. So Interpreting the direction is not important. If you leave your answer with a negative, you do not get the mark for the final answer. Just remember that. So we don't have negative answers. Those negatives represent some aspect of that motion, usually direction, for vector quantities. Anyway, guys, so easy stuff. They didn't punish you guys on this one. So 3.4 says, draw a displacement time graph for the motion of the package from the moment the cord breaks until it reaches the ground. Now it says take the ground as a reference point, meaning it's ground 0. All right, indicate the following: the time t, yes, this is when it reaches maximum height, and height h from which the cord breaks. Well, it's not a problem. I wonder if we have to calculate the value of height h, but I don't think so. Anyway, we know that this is going to be the displacement time graph of object, whatever this is. Now remember, we are taking up as positive. It's very important to do that. And of course, we're going to have axes. But remember, the baseline is the ground, so we're not going to have the negative axis. So this is position, or the question, the thing said displacement, let's say that, in meters. This is going to be time in seconds. Right, so what are we saying, folks? We know that this object is going to come up from this height, go up to maximum height, and then oops, goes to the ground. It's as simple as that. So if we decide, we can say this is height h, because nobody cared to tell us when it reaches maximum height, it is at this time. This time was 0.86. Did we get 82? Sorry, oops. Right, and then the time it took to reach the ground was 8 seconds. This is as simple as that. I'm not too sure if we have to bother ourselves working out height h, because nobody said we have to. As long as we indicated it, it's good enough. So obviously, guys, we get a mark for the shape. We know that this is parabolic, and for indicating the time that was required, and obviously the height h, and maybe the last mark for everything, I guess, you know, making sure the axes are labeled, the graph has a topic, whatever you call it, a label. And maybe the extra mark would be working out h. I'm not too sure. You will have to consult the memo, but I don't think they were forthcoming in terms of they're saying the value of h. They didn't tell us that. All right, guys, so that's it. Easy 12 marks. You smile and move on. So you see here, they didn't punish a lot. Usually this question is a punisher. Right, let's get to question 4 without wasting time. So question 4 says a cannon has a mass of 2,150 kilograms and fires cannonballs during a routine training exercise. Each cannonball travels at a speed of 70 meters per second to the right when it leaves the cannon. Okay, take the initial velocity of the cannonball before it is fired as 0. Okay, so technically this is the final velocity. And remember, when the cannon shoots, remember this is essentially collision. The gases, as they explode inside the chamber, they apply a force on the projectile, the bullet, as well as the bullet does to the gases and effectively to the chamber and effectively to the gun or whatever the cannon is, and hence there would be a recoil every time this happens. So it's an impulse moment already there. Okay, now we're told that the cannon fires 100 cannonballs per minute. 100 of them. Okay, the mass of each cannonball is 50 grams. Now we don't work with grams, so you have to divide that by 1,000, right? You must, there's no excuses. So this is going to be 0.05 kilograms. Automatically do this before you sweat. Define in words the term impulse. Again, guys, we spoke about this, and you can see it's quite a popular question. So 4.1, what is an impulse? We said this is the only formula where you describe the left-hand side instead of the right-hand side. So an impulse is a force multiplied by its time duration of action. So we can say it is the product of force and its time duration of action. Right, because remember, this is going to happen for as long as there is contact between two objects. That's the impulse, and once that is over, the impulse is over too. All right, folks, so that is essentially a very simple one. It's a product of force and its time duration of action on an object, if you want. Whatever. Easy, 2 marks. This should be 1 mark, by the way. 4.2 says calculate, and we're only looking at magnitude, so you may not have to worry about direction. So let's see, 4.2.1 says the momentum of each cannonball when it leaves the gun. So this is easy. We know that momentum P is equal to mv. So this implies that P is going to be the mass, which is 0.05, multiplied by the velocity. Therefore, P is very easy. So this is just 3.5. Remember, 2 decimal places or no decimal place. 3.50. This is kilograms meter per second. Now, of course, this is positive, it's to the right, but nobody cares about direction at this point. Whether it's wrong or right, it doesn't compromise anything. Simple. Maybe the mark here is for the conversion because you wouldn't see it coming. This should be 2 marks otherwise. Anyway, 4.2.2. Now it says the net average, hate that word, the resultant force that each cannonball, can you see we're just talking about one cannonball. Although they told us a lot that there's 100 of them per minute, but we just want one, not the total, the sum total of all those ones. So all of that information was just unnecessary, I believe. But remember, that is frequency, that is per second or per minute, they said, because for us to find the force we will need the time. So actually this statement comes in. Wow, I thought it was not necessary. Turns out it is very much, comrades. Anyway, we're gonna have to think about that. So the net average force that each cannonball exerts on the cannon. So obviously, guys, we know that the impulse, the change in momentum is from 0 to 3.5. So we know the change of momentum is 3.5. And we just need the time. So we have to think about these things? How will we find the time? Tell me, comrades. You can see it's 5 marks, this thing. And it's not 5 marks because it's difficult. It's just, you know. It is what it is. So what are we gonna do? What are we gonna do? Now, 100 cannonballs per minute. Then it means 1 at what time? Because in 1 minute, there's 100 of them. But now we need the time duration for just 1 cannonball. I think that's the most important thing. Okay, all right, okay. Now let's see. We can say to you and I know that I'm firing 100 cannonballs in 1 minute, right? Then, how many, what would be the time duration for just 1? I think this is, excuse me, this is what we need to think about. And if we cross multiply, what are we going to say? We want to know the minutes for just 1 cannonball. So this is going to be 100x is equal to 1. Therefore, x is going to be 1 over 100. Can you see that? So what is x therefore? X is, this is 0.01 minute. Now remember, we want our time in seconds. So we can say therefore x in seconds is going to be 0.01 times. Remember, in a minute there's 60 seconds. We multiply by 60. We times that by 60. This gives us, guys, a 0.6 seconds. I don't know if you know how to do this, but yeah, this is the one. This is the one, guys. This is the one. This is the one. So, I don't know. We could have, but I mean, this answer is already good enough. I mean, I kind of took a long route here. One could have easily said this is 60 seconds. Then do the calculation. You would have 60 over 100. Right? This one goes 0 to 66 times. You see that? But of course, you may have to add the extra digit because we were told, yay, 2 decimals. But since this is an intermediate answer, nobody cares. So we could have done it straight up and said 1 minute is 60 seconds. Maybe let's refine this. But you follow us. Because let's say you didn't think about it initially. But for those of you who are very sharp and very concise, we can say, well, we shot 100 in 60 seconds. Because a minute is 60 seconds. So if we want to shoot 1 cannonball, and what would be the time? So cross multiply. What do we get? We get 100x equals 60. We get that x is going to be 60 over 100. Therefore, x is going to be 0.60 seconds. Nice and easy. Of course, guys, I made this look like an answer. It's not. Okay. Excuse me. Excuse-moi. Yeah, I'm thinking. So, of course, guys, that's the time of contact for 1 cannonball with the chamber. We can say then, we know that the resultant force multiplied by the time duration of its action is going to give us the change in momentum. This implies we're interested in the resultant force. The time duration is now 0.60 equals the change in momentum is going to be 3.50. Right, because it's from 0 to this, so the final minus the initial is going to be that. There's no question about it, guys. So the resultant force is what we see. So therefore the resultant force is the force. Is the force 3.5, it's divided by 0.6. There's quite a small force, This is 5.83 newtons. Now, we only wanted the magnitude, but in which direction would this be? It would be to the right because it came out positive. So treat vectors with some respect, guys, even if it's not demanded. You know, most your parents, they don't say mama, say dada. They expect you to do it, even if they didn't say it. If makekbiza, wena nkuthala, awuzivela uthi yeba, batsho abantwana baseGoli, yebo. I'm like, uthi yebo ebutini omdala, ndathi xa ndifika phana ndaxakana nento, abantwana bathi yebo, hayibo. Kuthe, yeyi wena izapha, yebo, hayibo, kanjani, uphi umama, siphi isimamva. We always put a suffix, guys. We say, ewe mama, ndiyeza mama, ndiyeza tata, ndiyeza bhuti, ndiyeva sisi. Awuvele uthi ewe qha. Ndafika eGoli, into zaseGoli zikhala ngoyebo. Ya, yaka, bathi yaka. Qamba, ngeseziqhwakeza phambana. Ezelalini yam, ngeseziphambene yanguqhwala. Ngoba ke siyaqhwaba thina, phana abantwana abangenangqondo. Anyway, guys, some belief doch. Right, so you can see, guys, that some information is given so that you are sweating and you are crying. If you don't know ratios and proportion, you're gonna die, because this is your friend. Remember, guys, I teach you these things not for fun. Remember when I told you about King Henry dying a miserable death common to mankind? How that is done, this is the basis for you to survive no matter what is presented to you. Anyway, guys, I can talk until Jesus comes. You will probably not get it. Right, so that is the 3 marks. And the 4th mark is knowing how to find the time in seconds. How you went about it is your problem at this point in time. Okay, guys, so that's easy. Hey, 5 marks now, man. 1, 2, 3, 4. Okay, all right, okay. We can say, well, for your method, I mean, who did you kill? We can give it there, we can give it elsewhere. It's honestly up to you. Okay, so I can give you 2 marks for that, and then yeah, the final finish. This question is not too difficult after all. Hey, wait, the net was each cannonball exerts on the cannon. It can't be to the right. This one must be to the left, because remember Newton's 3rd law. I wish the direction was included here. In fact, the way this question looks, for me, I get the feeling the direction was supposed to be there. But why did they put this word? Why? Because that question, the last one, I have a feeling the extra mark, the 5th mark, must be for the direction, because although the answer came up positive, this means the force exerted by the cannon on each ball, because we saw the balls changing their momentum. So it is because of the cannon. But that same force is the one that the cannons exert back, the cannonballs, exert back onto the cannon. So it should be in the opposite direction. And I think for that, this is significant for a mark. But since the statement said magnitude, well, whatever. But as you can see, guys, questions on this topic are usually easy, but they can be made complex, as you saw in the November 2025 DBE exam. they put a graph in there, and the student who doesn't know how these things relate to one another always gets lost. Okay, it's always the situation. But if you know from functions, which function is this formula? Can anybody tell me? What formula does this look like? You know it. It's y equals mx. Now, who's the constant? Who's the variable? Did I hear that? I didn't. Who is the constant and who is the variable? Tell us, comrades. Who do we plot against who? Yes. You know that time is plotted against the change in momentum, usually. Of course, I can decide otherwise, of course. But under normal circumstances, this would be y. This would be the gradient. This would be the variable x. Right. So this is y equals mx, because normally we draw something against time on the graph. So we would assume that the resultant force stays the same because we didn't change the mass of the object. But if we decided to vary these objects' masses, then the whole story would change, because now what we would start to see is the fact that the change in momentum would be different, and the time duration of contact would be different. The resultant force would be different. But in any case, I think and I believe that we can decide that the contact time is constant. Then the forces would have to be different for different masses, isn't it? Anyway, guys, that's just me talking, not necessarily supposed to, but yeah, I just did. Anyway, guys, now we get to the organic chemistry, which is, where you're gonna score some easy marks. In fact, I would suggest, if you open up this question paper for term 1, shoot straight to organic chemistry, because it's very annoying, but it's easy at the same time, and there's a lot of marks on offer there. So go straight to that section, get your marks, leave whatever you can't figure out, then go back to these very technical situations. But again, a strategy, guys, is not consistent. I mean, you don't really worry too much about how many marks you're getting. Sometimes you get fooled into thinking you're gonna win. Remember, your brain needs to be fresh for difficult questions. You can't answer them when you're tired. That's the one thing I know. And it's always the case. I have seen myself during my tutorials with my students. When I'm tired, if a question is a bit elusive, I tend to fail to have the patience for it and to get it right while we are in the class. I start panicking, then I start losing my thought process altogether, and I end up leaving that question. But guess what? The moment the class is over and I get to relax a bit, I'm not under pressure, then the whole thing comes back to me as to how I should have done it. So all I can tell you, it doesn't matter who you are, experienced or not, sharp or not, when you are tired, your brain doesn't function at its maximum. It only functions at the survival mode. That means it wants to use less energy and effort to go on. So easy questions, no matter how many they are, they can be answered easily with less effort. But tough ones, you're not gonna do that, especially when time is against you. So rather start with the hard questions, whichever you consider hard for yourself, then handle those, finish them, then come here and relax while you scoop up marks. Okay, now let's get to business, guys. This is nice and easy. So what I often do is that just study this carefully. Now it says letters A to F represent 6 organic compounds. Of course, we can see that the triple bond tells us we have alkynes. Now, obviously, guys, just do yourself a favor. Try to establish which one is the longest chain here, because you're going to have to give the name. So let's see. If we start here straight, always check the straight first. 1, 2, 3, 4, 5, 6, 7. So there's 7 carbons on the straight chain. How about we bend it? Let's start from here. 1, 2, 3, 4, 5, 6, 7. Good. Let's bend it more. 1, 2, 3, 4, 5, 6, 7. So we can easily see that whether we bend it or we leave it straight, there's 7 carbons. How about we start from this end? 1, 2, 3, 4, 5, 6, 7. How about we change it back again? 1, 2, 3, 4, 5, 6, 7. Can you see? The longest chain, no matter how we look at it, is 7 carbons. So when the straight chain represents the longest chain, keep it at that. Don't bend it, because it's going to be very technical to label sometimes when it's bent. Although you may not have a choice in other instances. But if the straight chain is the longest chain, or at least represents the longest chain, keep at that. Now you don't want to name this and waste your time. You just move on. You've established what you need. Where's the long chain? How many carbons there are? And you know it's an alkyne. That's all. The next one, we've got a CH3 8O. So what should this one be? Now let's look at that formula. So this is CN H2N. So C3H2N would be 6 plus 2, and then an oxygen. So we know that this is the formula for alkanes. Once you add an oxygen to alkanes, we get an alcohol. So this is an alcohol. That's all you want. If you've got a molecular formula, you just want to know which one would it be, and that's it. Now C is C4H8O. Okay, this one is C4. Okay, I don't know, guys. This one didn't come out nicely. So this is H8O. Now, this is the formula CnH2nO. Now, once you see this, this is for alkenes. And once you see an oxygen, it's part of the carbonyl group. So it's either an aldehyde or a ketone. So for this one, you wouldn't be too sure. But normally, once we end with a CHO, we normally would be leaning towards aldehydes. And if this O is incorporated before that, we would probably be leaning towards ketones. But it can be either, because why? The two are isomers of each other. So you wouldn't know from the molecular formula what this is. So here we know that, okay, we are either looking at a ketone or an aldehyde. Then we go on. D says CH3CH, and then there's a CH3 in brackets. Once you see a CH3 in brackets, it means it's a side branch. So this is a branched chain. This is a branch, okay? Then COCH2CH2. Can you see what I meant? Now, if you look at this, this O is in between two carbons, right? And this is most likely a ketone, because there's only one oxygen inside the chain. So it can only be a ketone. So most likely a ketone. And if this is a ketone, most likely this one is going to be an aldehyde. Again, we're not sure. But we are sure about D. It can only be a ketone. All right, so we look at E again. We see that this is an alkene because of the double bond. Now let's find out who's the longest chain. 1, 2, 3, 4, 5, 6. How about we bend it? 1, 2, 3, 4, 5, 6. How about that? 1, 2, 3, 4, 5. It's even shorter. So the longest chain has 6 carbons, and we'll leave it as such. Okay. So if the straight one is good, it's good. Now we don't care about other issues. Leave them alone, because you don't want to waste time doing this and then you end up suffering. Find that what you did was not even necessary. Now F, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So this one, can you see, is bent, and there's nothing you can do about it. This one is bent, and that's the longest chain. And then of course we see that these are haloalkanes. Okay, so that again, it's a haloalkane and it is branched. So let's leave it. Let's get to business. 5.1. Write down the letter that represents a compound with a 4-mel group. Now, 4-mel, sometimes it's not different from the carbonyl group, right? But yeah, we assume it to be for aldehydes, because for ketones, we would say the carbonyl group is bonded to 2 other carbons, right? Right, so this would be carbonyl, but if you look at it, it's still the same thing. So this is the carbonyl group, but when it comes to aldehydes, we often try to differentiate the two, but technically speaking, that's just the carbonyl group. So obviously, what did we say? This dude is definitely an aldehyde. Since we can see that we saw a ketone on the other side, and this could be represented by that, even if there is another one that we missed, but that one in particular may still be represented by that letter. So essentially, guys, we got it. So we know that it's going to be letter C. 5.2. Write down the IUPAC name for the compound. Now, can you see it's only 2 that are asked? So you may have wasted time trying to name all 3. So it's just nice to make it light by getting ready. Compound A. So we know that A, the longest chain, is that one. Now remember, for these ones, we always prioritize the the triple bond. Now we must have the shortest distance to the edge from the bond. If you look here, 1, 2, 3, so it's on carbon 3. But if we come from this end, it's 1, 2, 3, 4, so it's on carbon 4. So this means this must be carbon 1, this must be carbon 1, 2, 3, 4, 5, 6, 7. This is carbon 7. So this is good. So this already tells us without any shadow of doubt where we must supposed to come. Now this can create questions, because part of the IUPAC ruling says, if at all we've got more branches from the one end than the other end, then we must go through the most branches before we can, but this is only for symmetrical. If this was in the middle somewhere, where we've got the same number of carbons from one side, then we start prioritizing the branches. But at this point, priority goes to the functional group, then everything else will follow from there. So technically, this is now 2, comma, remember this is a methyl group. And this is also a methyl group, right? But this one is an ethyl group. There's 2 carbons there. It's an ethyl group. So what are we going to say? So this is 2,6 dimethyl 5 ethyl hey, now this is a bit of a problem. Who comes before who? Now I'm thinking about M and E. But does the D of di change everything? Yeah, this is where it gets a bit hot, I think. It gets a bit hot. Because we have a di there. Does the di take precedence over ethyl? Or do we say 5-ethyl, 2,6 dimethyl? I'm confused, guys. But anyway, we're going to look at the side branch. I think the di part is not really. Is it? Try, di. Does it matter? I think it does not. I think those things don't matter. Anyway, guys, I'm not too sure about the answer here, so you're going to have to check the memo and also double check from your teachers. But I think let's start with the ethyl. So this is going to be carbon 5. So this is 5-ethyl, 2,3 dimethyl heptane. Right? Yes. I think this is the one, guys, but yeah, you can double check this one. I don't think this prefix matters in terms of the alphabetical labeling, but I think the E comes before M, and that should be enough. Okay, so let's just leave it at that. Of course, guys, this one is a bit tricky, and you can see it's 3 marks. There's no play here, so you get a mark for this, get a mark for that, and the parent chain. Nice and easy. I hope we are correct. 5.2.2. So please double check this one. I'm not too sure anymore. F, yeah, that's the one. So we saw that this is a haloalkane, but now there is some issue. I don't understand whether this is agreed upon or what, but it seems that no priority is given to the functional group when it comes to haloalkanes, which I have a problem because why? Maybe the indication is that we can have more than one more than one type. So who takes priority? Again, alphabetical order, I guess. So I don't know, guys. Even with these alkenes, there can be multiple. At varsity, you will see you're going to have things like tri-ene, di-ene, when there's 2 of the double bonds, 3 of them and all that. So I don't know. I still maintain the functional group should be priority. But in any case, I guess because in grade 12 chemistry, maybe we can say in some way it may sound right in that for grade 12 for high school purposes, we never see multiple functional groups added except with alcohols and with haloalkanes. The rest we almost always have just one functional group within the molecule. But then the alcohols, why do we prioritize the damn OH group? Because it behaves in a similar way as haloalkanes for high school chemistry. Do you see? As much as it wants to make sense, but it doesn't really make sense, okay? But I think for your syllabus, guys, maybe we can say that now and say for your CAPS curriculum, it has been decided that you'll never have more than one alcohol, because we used to have more than one, if I remember well, unless I think of university or so. So maybe because this is the only homologous series where we can have multiple of these, and maybe this is why it no longer takes priority, because I've not really seen a tri-all and di-all, but I think it is very much possible with alcohols for high school. Anyway, guys, we seemingly do not take priority there. We just treat it as a side branch, it seems. Now let's see. The longest chain is 1, 2, 3, 4, 5, 6, 7 carbons. Now, which side lends us into our first branch? If we come from this end, 1, 2, 3, the first branch is on the third carbon. But if we come from this end, we get this branch on the second, and on the third, we have another branch. So it says, if we have this situation, we must come from the side where we will meet the most branches. So this is carbon 1, this is carbon 7, okay? Right, so what are we going to say? Now this is methyl and bromine, so B come before M. So we've got 2, 3 dibromo this is now 2, 3, 4, 5 methyl heptane. Okay, so very interesting stuff here. So again, we're getting the mark for that, and for that looks like we're not getting the heptane. I don't know why, because that should be 3 marks. Actually, yeah, that should be 3 marks, but since everything was a heptane, I suppose they decided you're not getting it again, which makes sense. So 5.3. We are now supposed to do a definition. Again, guys, understand these things rather than cramming these. As you know, a homologous series is a group of organic compounds, in this case, that can be described by the same general formula. And of course, these share similar chemical and physical properties. But we may not go there because this is when we are bringing in the functional group. But of course, they have the same functional group. That's what makes them a homologous series. So you can just say it's a group of organic compounds with the same functional group. But I think for the sake of avoiding a definition within a definition, because remember functional group can be defined as well, maybe let's leave that alone and say, okay, let's rather, for being exact, avoid using a definition within a definition. So let's just say it is a group of organic compounds that can be described by the same general formula. Okay, tabadisalanile general. Why one? Yes. Tabadisalanile general. So what is important, guys, is the same general formula that describes a group of these organic compounds. I mean, there's not a lot of technicality there. I think it's best to state this so that there's no definition within a definition, okay? If you use the same functional group, it's okay, but I may ask a question further. What is a functional group? Do you even know what you're talking about? So avoid things that, at university they used to tell us during the clinical years when we go to the hospital for most of the work. So when they ask you a question, it was advisable to not say things that may stretch those questions because you still have a lot of tasks to complete. So you try to be as precise as possible. Do not add things that can stretch the questioning around a thing, because if you are found wanting in what you introduced, they automatically fail you because they take you as someone who's a chancer. Because you cannot do that to a patient. They come crying of a pain in the back, and then by mistake, you test the urine, but you don't know why you are testing it, and then you realize that there's nitrates in there, and then you're going to treat them as a kidney infection, when in fact, it's a spinal pain. But it's just in the proximity of the kidney. What if there's a disc that is pressing on the spinal nerves there? And it's not the kidney, but it's the same region. So this is just to say, folks, you need to know how to differentiate things. And if you introduce stuff, you are more likely to find yourself in trouble. I see a lot of doctors these days. Someone comes complaining of something. Then because they think, if I pull the blood, I'm going to know what's going on. They just pull the blood, and the blood comes with an abnormality of some sort. Perhaps it's just a lab error. They don't know. Then it comes saying, your hemoglobin is low. Then they will just say, it's because of your hemoglobin, so you need hematinics. They give you iron tablets and send you back home. But actually your tiredness has nothing to do with the low hemoglobin. They may be missing something there in this patient. So, guys, what can I say? There's a lot to think about. So I'm trying to force you folks to not become too complacent. I know you take these subjects for granted because somebody tells you, no, you're not going to need them. You're going to become a doctor. No, folks. No. You're going to make the worst of that kind that you're trying to be. I am seeing it a lot around me. People with just poor insights because if someone never told them, and again, even that someone has to be someone they respect, because if it is someone they don't respect, they're more likely not to listen, even when they get told, until they run into problems over the same idea, and only then they would know. But even then, they're undecided if it was coincidence or it was true. So this is why, folks, you need to pride yourselves with the knowledge that you acquire. Please acquire it. Don't bump into it. Acquire it so that it's yours and you can use it even when nobody can think of using it. You should be able to. As I said to you guys, all these functions I have seen where they are applied, and I think in some of the videos I've told you about this. Think of a hyperbola, for example. You know, when we measure the blood volume in the brain, or cerebral blood volume as we put it, you know, the manner in which we use an MRI scan, the algorithm that it uses to do this, it's hyperbolic as a function on the Cartesian plane. And you will see people running around telling you, I just know how to pass these things. You're not gonna need it. Nonsense. They don't know what they're doing. This is why they handle these things wrongly. Say, for example, someone presents with a stroke in your hospital and you are the doctor on call. And remember, if you miss it as the doctor who sees that patient first, others are more likely to follow your incorrect, incoherent, and irrational thinking. Because if you missed it, they're more likely to follow on what you said. And when that is found wanting later on, then they'll say they don't know what's going on. Because automatically, their thinking is narrow from what you did. So if you broaden your horizons, then they are forced to think outside the box themselves, because then you already present a problem. So when you don't know what's going on, don't say or pretend you do. Stretch it as much as you can. Even when you do, state it that those are suspicions. They are not a confirmed thing, okay? So that anyone who thinks about the case, they can apply their mind instead of just following on your footsteps. So this someone comes with a CVA, a stroke. Maybe it's just happening for the first time. And maybe it's within the time frame that you can treat this patient and the stroke goes away. Let's say they present within 3 hours. Remember, you only have 3 hours to treat someone with a stroke. Otherwise, it's over. Now let's say it happens, they live close to the hospital and then they come in within an hour of this incident. You do a CT scan. I mean, mind you, some of the CT scans we have are fitted with perfusion analysis or something where you can check the blood volume, you know, all of those things. Now, if you're not someone who thinks in this manner, even those kinds of technologies may not prove useful in your hands, because you won't know how you're going to use this. But someone who's good would also know when there is an issue. Let's say, for example, they see that, okay, the blood volume is decreased on one side of the brain. Remember, it's two hemispheres. So you check, okay, in this region, there's a decrease. So this is already trying to tell you that there's poor perfusion there. So one vessel is blocked, okay? So you can quickly do a CT angio on that patient. And then the angio will show you exactly which vessel is blocked. From there, you can take this person to an angio suite and do an embolectomy. Either remove those clots by trapping them and taking them out, or you go and inject something directly to the clot and dissolve it, and blood flows within 3 hours, and that person will have those symptoms of stroke recovering within a few days of physiotherapy and all. So what I'm trying to say, you will not know, because if you just do a CT scan, it looks normal. Nothing is wrong. But if you do a perfusion scan, you will see that there's a decrease in blood volume there. And if there is such, that means the vessel is blocked, because sometimes you don't get the typical signs of a hyperdense vascular sign on a CT scan, which would tell you that there's a blocked vessel, because it shouldn't be hyperdense before you inject contrast. But what if you don't have that? The clot has poor calcium content, so you won't see it. And maybe it's new, it's not old, you won't see it. It will look almost like a normal vessel. So these things, guys, I'm telling you. So essentially, it starts here, knowing things for what they are, because this way you will be able to use your knowledge even when nobody said. I don't even know what I was talking about now. So you see, I'm one of those crazy people who forget what they are talking about. I should stop talking too much. Write down the general formula of compound E. Do you see this? Now, compound E is an alkene. So alkenes is CnH2n. And if you forget, to just take a simple alkene and see. There's 2 carbons, there's 4 hydrogens. So this is the same as Cn. So you know that most, if you divide by 2, there is going to be CnH2n. All alkenes are like this. Is like this, is like this, is like this. All right. If you forget, give it. Don't worry about the branches. Can you see? Branched or not branched? Functional group, it's an alkene. Done. See? Easy. This should be 1 mark. Come on, guys. This should be 1 mark, you know. Unless they were telling us to write a molecular formula. Maybe that would be something. But it says general formula, okay? 5.5 says, write down the structural formulae of the isomers of compound C. Do you see what I mean? Yes, I told you. I tell you these things. It could be either an aldehyde or a ketone. Now there's 4 carbons, so this is good. So let's do this one. So let's say this is an aldehyde. So this is what it's going to look like. Please, everything must be there. Okay. So let's see. This is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And then oxygen. Yes. It is the one. And then the second one is 1, 2, 3, 4. The carbonyl group can be there. Come on, battery. How did you go down so fast? Again, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, and then oxygen. So can you see, it can either be, and the nice thing about this one, even if you put the carbonyl group here, it's still the same molecule, but you can't place it at the end because it becomes an aldehyde. So this is 2 marks, obviously, for the functional group and the rest of the structure. Functional group, the rest of the structure. We hit our 4 marks with a large smile on our face. Right, what visible change will be observed when bromine water, now this is part of the experiments we've done, is added to compound E? Obviously, it becomes colorless. You see that brown water disappears color because an addition reaction will take place. So we can say it decolorizes, or it becomes colorless. Okay, the brown water changes to colorless. Okay, we can just say the brown water, the brown water turns colorless. Right, because an addition reaction takes place. Remember, here we're just describing an observation. We're not explaining why. So it becomes colorless. The brown water becomes colorless, or it turns colorless. Nice, easy, because the bromine is now taken up. Remember, haloalkanes are colorless. Yes, yes, yes. Okay, nice and easy. Again, folks, 1 mark. So this means for those who attend class and do experiments, this is an advantage. But for the bankists, tough luck. C3H8O. Okay. Now what is this? Is that compound we talked about. Is that compound, which is B. Compound C. Yeah, dog. This is B. So reacts with a carboxylic acid. Okay. In the presence of a catalyst. By the way, if we react an alcohol, a primary alcohol, and a carboxylic acid, we know that this is esterification. So our catalyst is sulfuric acid. Okay, to produce an organic compound Z, which is an ester that has 6 carbons. Okay, so this is fine. We hear that. So if it gives us 6 carbons, it means our carboxylic acid has 3 carbons. Because we already have 3 carbons from the alcohol. So these are some of the pieces of information that I just brought into your attention. And please, folks, make sure you are aware of what they imply. Write down the type of reaction taking place. Obviously, this is a condensation reaction. This is a condensation. That's the type. But some people would be, esterification is fine, but this is the name of the condensation reaction taking place. Remember, this is the type. Esterification is not a type. It's the name of the type. But when we say type, this is general. It's either condensation or it's elimination, addition. But if you think about it, condensation reactions are more like synthesis type of reactions. But where there's also a combination of synthesis and elimination, it's happening at the same time. So that's why it's so special. This is why when we say a condensation reaction, there's always water as a byproduct. There's something that is eliminated, but consistently it's water. As opposed to other types of elimination reactions. But remember, this is a synthesis. We are joining 2 separate molecules into one. Hence we say condensation or synthesis. But if we eliminate water as a byproduct, then we say this is a condensation reaction. Understand, don't cream. If you do, uzokhala wedwa. But of course, guys, this is acceptable, but I don't recommend it. Learn to answer the question asked instead of answering your own things. It's okay, but it's not fine. Name or formula of the catalyst used. Well, we know that is H2SO4, hydrogen sulfate or sulfuric acid. Some people, but don't write both. You give one, or you write sulfuric acid. Okay, sulfuric or sulfuric. But don't write both, write only one, okay? It's either or, don't write both. If you write both, you're not gonna get a mark. So you get a mark for either one of them, okay? But if you write both, you lose the mark. 5.7.3 says, structural formula of compound Z. Okay, so this is not a difficult one. So this is going to have 3 carbons, 1, 2, 3 from the alcohol. Then we know that it's going to be the oxygen. And then we know that this is going to happen, 1, 2, 3, 4, 5, 6. So this is now done. So this is going to be propyl or propyl propanoate. So the name may even be asked. It's propyl propanoate because we reacted propanoic acid with a primary alcohol, which was propanol. But of course we can say propan-1-ol or 1-propanol. If you just say propanol, you are dead because you're not telling us where that hydroxyl group is. Okay guys, this is not a big deal. You could have started with this end and ended with that. Not a big deal at all. So you get 2 marks for this thing. Can you see guys, 19 marks in here for nothing. Absolute zilch. Okay, let's move on to question 6. Question 6 says, learners use 3 primary alcohols, A, B, and C. Can you see? They are primary. Hey. Now, what does that mean? By definition, what does it mean? It means the OH, the hydroxyl group, is bonded to a primary carbon, which is bonded to other carbons. That's the message. So it means this carbon is not a secondary carbon. The carbon here is a primary carbon, meaning it's bonded to one other carbon only. It is not bonded to 2 or 3 other carbons. So know these definitions, guys. Okay, with the same molecular formula, right? To investigate one of the factors which influences boiling points of organic compounds. So the most important thing, these are primary alcohols. They've got the same molecular formula. Whew. Now this presents a bit of a problem. Is it possible? Is it possible? Okay, let's see. Same molecular formula. Okay, one of the factors, to investigate one of the factors which influences the boiling points of organic compounds. Of course, we've got alcohol A has a low boiling point. Alcohol B has the highest boiling point. And then alcohol C has the second most high boiling point. So obviously it means A has less strong intermolecular forces compared to C and B. Let's just write down the term that can be used to describe the 3 alcohols based on the underlined words. They are isomers. If they have the same molecular formula, chances are they have different structural formulae. So we can just say isomers, 1, 2, 3, we can say isomers. Now folks, you may want to think about it. What type of isomers are these? Remember, if they are primary alcohols, that means the problem is with the longest chain. So you can say these are chain isomers, because the functional group is not changing position. Otherwise, if it was, we would call them positional isomers, which is not the case here. So if they are primary alcohols, that means the position of the carbon is on a primary carbon, and that means it's in the same position. Okay, it's at the beginning, it's never anywhere else. Now, this can only be, they can only differ because of the chain itself being branched or not branched. So I wonder, if you say chain isomers, what would happen? Because I feel like this should be the case. You can say so. You can say these are the chain but if it is just one mark, I think isomers alone would be good enough. But if this was 2 marks, I would lean on adding the word chain, because this is already telling us that it's just the chain length that changes, but the carbon bearing the functional group is the same for each. All right. As you can see, guys, some answers you need to be as technical as possible to be exact. Define the term boiling point. Again, guys, definitions. I don't know how many times I've been singing this. So this is the temperature at which vapor pressure of a substance is equal to the atmospheric pressure. Okay, it is a temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. Right. So that's the boiling point. Yeah, I hope I'm saying the right thing, but why do I feel like it's not complete, eh? But of course, keyword is that this is a temperature where the vapor pressure is equal to atmospheric pressure, guys. I think this is good enough. This is when the atmosphere can no longer take more of the vapor, so it starts boiling. Now name the independent variable. Remember, the one that changes. What are we changing? It's the chain length. That's the independent, because as you could see, I said these are chain isomers because we have not changed this position of this thing. So what we are changing is the length of the chain. So this is the chain length. How many marks was this? Yeah, doch 1 mark. Bafethu anmen kancane 6.4. Can the above investigation be described as a fair test? Give a reasons for your answer. Well, yes, we can say so. The reason for this is that these are of the same molecular formula. This means they have the same molecular weight, so they have something in common. And nice enough, they belong to the same homologous series. So that means their chemical properties are not expected to be different. As you could see in the MCQs, we're not really having a fair comparison, but of course we had to face reality of some sort by playing our cards right. Remember, the molar mass has more information for you than you ever imagined, so I'm sure you saw how we can use it, even though we probably have never heard of such a thing before. But it makes it a reasonable understanding that once we have a higher molecular weight, it means there's more electrons involved in those molecules. And the more of these are, the stronger are going to be our induced dipole-induced forces, or the London forces, or the forces of dispersion as they call them. Anyway, guys, so we know that this is a fair test, and the reason is that these have the same molecular formula. So the compounds have the same molecular formula. You can even say the molar mass and belong to the same homologous series, meaning they have similar chemical properties. So in essence, guys, we are more than happy here to get our 2 marks. Even one of saying they have the same molecular formula, that's what. They have to have something in common, but this is an added one. To say they belong in the same homologous series, it already tells us that we expect similar chemical and physical properties. Anyway, guys, so do you see that answering here is not just bumping into answers? It's intentional. It's knowledge-based. Right, which alcohol, B or C, will have a higher vapor pressure? And of course, fully explain. Of course, guys, I have shown you this. This question is always common. It looks to have lots of marks, but these are cheap, big marks on this question. Because to answer this question is always the same. Let me get a cord to... And I need to finish this tutorial so that I can clean my house. I must clean my hair. It's dirty now. I'm investing too much time into your mistake things here. And I'm abandoning myself here. If only you knew these things, people, you would understand the depth that they go. You see, we neglect ourselves to make it better. And nina ngapha nithatha nje for granted. It's for granted for you. Adlala ngamandla ethu ngoba asithole support. Ela xesha ndilibele ukubhibhidla apha amazinyo abolile. Qhela kabi. Siqhela kabi. Futhi ningangijongi. Bafuna abantu abanjongayo. Yeah. Anyway. Right. Now it's connected. Before we lose the power. We're almost done, guys. Let's try and just finish it within these 3 hours. Remember, this was a 2-hour one, but of course for me it's teaching. It's not just answering, guys. Teaching. Remember, you need to build your endurance so that you can learn to sprint even when tired. Ne? Now let's talk about it. Who between B and C has a higher vapor pressure? Remember, vapor pressure and boiling points are inversely proportional. The one with the higher boiling point will have a lower vapor pressure at a given temperature in comparison to the one with the lower boiling point, which will have a higher vapor pressure. So technically, the one with the lower boiling point of the two will have a higher vapor pressure. Right. So let's say it's going to be C. Remember, the question said which alcohol. We now need to say that the one is going to be C. Why? Now we start making our bullet arguments. We can say C has a lower boiling point than B. That's the obvious thing. First, you state the obvious. Remember, you don't just take izinto from emoyeni. Uqala ngale oyibonayo bazohluke ngantoni. Le yona ibila qala kunaleya. Sithetha ngombilo, boiling point, umbilo, right? Yes. Khona into engiqhela kabi apha ekufanele ndiyibulale. Damn it, makokorosh. Qhela kabi. Ayike likokorosh izincuncu. Dala zincinci. The second thing is to suggest if this one has a lower boiling point, it means it has less strong intermolecular force. You can say C has, therefore, less strong intermolecular forces, then B. Essentially, you can even put it essentially, suggesting that it has a shorter chain. Essentially linked. You know, most on isilungu esininzi uthetha noba intoni oyithandayo noba kunini. Essentially linked to its shorter chain. Remember kuthiwe chaza ngokupheleleyo, explain fully. Asifuni into ezixabuzelayo apha ikhaphetshu engavuthwanga. Zasibangela umsuzo omninzi. Okay, sifuna usuza thina. C has therefore less strong intermolecular forces than B, essentially linked to its shorter chain. Do you see? I'm putting everything on the line compared to B. You see, you are comparing here. B would have a longer and of course stronger molecular forces linked to its longer chain. But you don't have to talk about these ones individually. You just compare. You can say, then C requires, you never stop without talking about, requires less energy to separate its molecules than B does. Nice and easy. You can say, therefore, C would have a higher vapor pressure at a given temperature than B. You see this, you see this, you see this. Okay guys, so what do we say? We say here, to structure an answer to this question, you always state how they are different, because that's what you have on the table. Now you start to put an explanation for why it is so. You are going to tell us that it is because of stronger intermolecular forces for B compared to C, which is linked to the shorter chain length of C and a longer chain length for B. Right? You may even add that, which would have a longer chain length. You can say compared to B, which has a longer chain length. You may even put that. Remember, we want to put it fully, but if we said one is shorter, obviously the other one must be longer. Then C requires less energy to separate its molecules compared to B. Remember, the conclusion, guys, has already been made, but it has to come in to close the argument. But we've already gotten a mark for it there by making the choice. Can you see? Easy 4 marks, guys. You never finish talking about physical properties of these if you don't mention how they differ, why they differ, and the energy requirement, because all of this has energy at the center of it all, or you may even call it the common denominator is the energy. If in your arguments you don't mention energy, you are dead. Remember, again, the numerator to this is the intermolecular forces. Yes, yes, we have to talk about it. Right. Okay, all right, okay. Now, folks, we've answered that question, I believe, in our best of ability. And let's just move on without wasting too much time. 6.6 says, how will the vapor pressure of C at 29 degrees Celsius compared to that of B at this 149. Now, if you notice, these are the boiling points for each. And what do we define the boiling point by? Hey, Nina. It is the temperature at which the vapor pressure is equal to the atmospheric pressure. So what does that mean? They must be equal to. Although they are different, but at their boiling points, they each have equal vapor pressures. Why? Because they equal to the atmospheric pressure. The atmospheric pressure is a constant, essentially. Although there may be some variations depending on altitudes and stuff, but hey, we assume, or at least we accept it as a constant. So if anything is equal to a constant, and then another thing is equal to a constant, then those two things are equal. Right. So it must be equal to. Nice and easy. Again, guys, just 1 mark. So this is linked at the fact that these two are at their boiling points. So each one's vapor pressure is equal to that of the atmospheric pressure, which is a constant. So if one part is equal to a constant and another part is equal to the same constant, therefore the two are equal, isn't it? Simultaneous equations, folks. I hope this is clear. It's quite a nice question, you know. It just begs understanding. Can you see term 1 exams, guys, are not a walk in a park, as we often say, because there are some provinces that take examinations seriously. But what I like about the ECs ones compared to other provinces, they ask you what you have studied, but in a very nice and, you know, manageable level for students, because yeah, I see a lot of brutality with, you know, other provinces that examine at a high level. They become outrageous. They forget that they're talking to high school kids who are still confused about their very own lives and identities. They try to be the next person, you know. They do not say, even though the next person may look to have something interesting, I'm just fine the way I am. I'm not making any effort to look like them. Not out of spite or anger or whatever you call envy. No, I'm just me. You know, flourish. It's okay. It's your choice. I don't know what demons come with that flourishing, but I know the ones I'm facing being me. I can handle them, so why must I change? Add to my troubles? Maybe. But if this becomes an absolution, well, it still lives to be determined when that happens. But it has to be my choice, because after that choice, you know, you're going to have to be stuck with all of the things that come with that choice, isn't it? Anyway, guys, that's it. That's it. Let's finish this question. Now, the molar mass of B is 88 grams per mole, okay? Now, write down the structural formula of compound A. But remember, this is for all, because we were told they are isomers. If they are isomers, they have the same molecular formula. Same molecular formula means same molar mass. Okay, let me say this. NB, same molecular formula, is equal to the same molar mass. So this means the molar mass of B is that one, 88. Okay. Now we want, So this means the molar mass of A is going to be the same, right? Right. That's the idea. So now how are we going to handle this? Remember, what did I say? I said CnH2n plus 2 plus an oxygen, right? This is alcohol. So this is the general formula for alcohols. Now we need to know how many carbons are here. Now we need to find the value of N, because N will tell us how many carbons we have here. So now if we've got this molecular mass, we know that, guys, carbon as an element on the periodic table is 12 times N, the number of which we need to know. Then we're going to add plus. Hydrogens, it's 1 into N, right? Into, it's 1 into 2N, right? 2n, okay, but we're adding on the hydrogen, 2n plus 2, right? Right, and then we're adding oxygen. Oxygen, there's only one, so its molar mass is 16. So this should give us 88. I don't know if you've ever seen this before, but hey, even if you haven't, you need to know that from the general formula of alcohols. This is because we know that this is CN H2N plus 2 plus oxygen. That's the general formula of alcohols. And we can now use the periodic table to find out if this is the molar mass, then we need to know what is N here. So we've got 12N plus 2N plus 2 plus 16 equals 88. So we've got 14N equals, this is 1888 minus 1870, right? Right, therefore n is going to be 70 by 14, that should be 5. Yeah. Right, so essentially, guys, there's 5 carbons. We can say, therefore, we will have 1, 2, 3, 4, 5. But now let's be careful. A has the lowest boiling point, so this means it's the most branched. Okay, now which one of these ones could it be? Let's think about it. The shortest chain length should be prop, isn't it? Prop. So 1, 2, 3, while we can have branches. So this is going to be the OH, and then the hydrogens, then this should be methyl branches. So yes, it should be the most branched. Again, guys, you need to be smart about this business. If you are careless, you are dead. As you can see, 1, 2, 3, 4, 5. This is the most branched. If it is less branched, which I suppose is B is going to be 1, 2, 3, 4, 5. This is going to be the OH when it takes the carbons. Can you see that? This is the one that is the straight chain. Then the other one is going to be branched, but not as branched as the other one. It's going to be 1, 2, 3, 4, maybe. And then we're going to put a branch here. Remember, a branch here is the same as a branch over there, because it cannot be anywhere else for it to be a branch. So this is why we know there's only one of this kind. Yeah. The one with the lowest boiling point must be the most branched, because the globular structure it forms, the less are these intermolecular forces, because they act over a short distance, and the moment the surface area is small, then they don't become as strong. All right, so we know that this could be B and this could be C, and that should be A. So again, do these, guys, to confirm that what you are doing is good. You would be dead if you didn't know. So this means this molecule, has 5 carbons, and it is what it is. So again, folks, this highlights the fact that you need to know enough mathematics. This is a higher grade question, because no standard grade student would know what to do under this circumstance, because they won't even know why they are being given the molar mass and what does it mean, and how could they use the general formula to generate an equation to work out how many carbons, because you can't draw a structure of organic molecules if you don't know how many carbons they have. So be very careful, guys. So the number of carbons is very important. Can even write here 5 carbons, because that's what we are interested in. Okay, guys, so I hope this one highlights some of the most important things. As you can see, you just get 1 mark for each. Wow, after suffering so much. How unfair. Anyway, what can we do? We take what we are given, we run with it, and we face other ghosts. Right, let's finish up question 7. Unfortunately, I took longer than the time I wished to because I started telling stories. But if you want to learn, learning takes time. And remember, the learning that takes time is the most important, because you start to feel comfortable with complex stuff without shaking. I mean, if I'm told I have to present tomorrow a topic, I don't sweat. I need to stop everything. No, I don't need to, because within 2 hours, I'll be done with my presentation. You know why? I know things. And I know things as I walk, effortlessly, because I take time to study them and understand them. So it takes me no time at all to create a presentation, to go and, give a presentation, and a good talk, by the way. Because I know I just need to research a bit on perhaps the newest developments in the field or in the topic. The rest I know from the ground up, and I can bring it alive better than any book you may have read or journal or whatever you may think of, because I go behind everything I see. And I do it when I'm not under pressure, so that I don't have to use working memory, which is short-term memory. I use long-term memory, because once you remember everything you did and you enjoyed and you were not under pressure, do you realize that you tend to remember it more than the thing that you do under pressure? You only remember it for a short while and it's gone. This is why most of the time people's painful pasts, they tend to forget the details, but the most important and the very nicest of them experiences, they tend to remember in detail, because those things come through your brain when it's not under pressure. Remember, when the brain is not under pressure, it works the best. The moment you put it under pressure, it goes onto survival mode. It shuts down certain things like emotions, all the other feelings that you would feel and senses. And yet, when you are at ease, all of these are unlocked. And as a result, the brain tends to use these very other functions as a way of remembering. Because it's not like the code has to sit in some place. It takes all these other things that were activated at the same time, because how they felt is exactly how the brain is going to remember. But if you shut them down, then it has nothing to compare with if the main channel is blocked or occupied or preoccupied. Anyway, let's go. I guess sunqhela unibisinkwenkwe ndiyagijima wako ungatsho na anikoni kuhambela. Is it what is to sing in Shutsonga? Shutsonga is disappearing from me. By the way, what is to sing in Shutsonga? Is to imbelela, right? Yes, it's to imbelela. I think so. I'm not sure anymore. Yeah, ita imbelela. So, I'm imbeleling. So, man. Compound B, okay? I told you the flow diagram, 1, 2, 3 represents organic reactions. Now, this is the topic that makes you sweat, students. So sit down, stop what you're doing, listen, don't write nothing, don't look at the phone, don't look at anybody, don't go to the toilet, you sit down, you lock in. This is important, because this is where you are likely to spend time not really making progress. I can tell you. But if you did well in other sections, enough to really pay attention to this section when you studied, then you won't spend that much time here. Anyway, so these reactions, okay, fine. A, B, C, and D represent organic compounds. Okay, good. Right, so now we've got compound A, and then it goes to compound B, and we are told major product Most likely this is unsaturated. Most likely. I'm not saying for sure. It could be something else, okay? But most likely, it is unsaturated. I'm not saying definitely, most likely. Because when we hear major product, we tend to add something in a particular way so that we have a particular structure. But it could very well be a substitution reaction. Remember when you're forming alcohols and all that? So again, the major product will follow some rules. Okay, but let's leave that. It could be an elimination reaction. Remember when you eliminate, Zaytev's rule talks about a major product. So this is either an addition or an elimination. Maybe not so likely a substitution, but it could very well be it as well. Right, and then we go to compound C. Now let's look at compound C. Compound C has an interesting friend within the molecule. OH. This is an alcohol. It's a secondary alcohol. Now the question is, on which carbon is it? The carbon that precedes that OH is the carbon that bears the OH. So it's on carbon number 2, right? Right. And of course, as I said, if you look at branches, folks, and you see a branch that has a CH2, it means this is within the branch. I mean, within the chain. It's not a branch. If it's a 2, it's within the chain. So this just means we didn't want to write a long structure, so we say shwangatela, we're summarizing. So basically, this is a carbon. Of course, we've got 1 times 2, so that's going to be 2, 3, 4, 5. So this is 2-pentanol, if you will, or pentan 2-ol. That's what this is. It's a straight chain secondary alcohol. Now, if this is an alcohol, right? If this is an alcohol, what do you think this should be? Well, this could very well be an alkene. It's possible. This could very well be an alkene. And we may have done what we call hydration. It's possible. Or it could be, if we assume this was unsaturated, this is most likely a haloalkane. And of this haloalkane, it's going to be of the major product, so to speak. I would assume a haloalkane here. Mainly because we do hydrolysis on haloalkanes to form alcohols. So this is most likely hydrolysis rather than hydration. But you never know. You are just thinking out loud. And now, if we said this is most likely unsaturated, compound D, if we went into a process of addition, reaction to form this could be very well be an elimination reaction or an addition reaction. At this point, we can't figure out much. But what we can do, we can draw the structural formula here. 1, 2, 3, 4. We said it's 1, 2, 3, 4, 5. So we said here the OH is on the second carbon. The hydrogens, I'm not going to add them. I'm just going to leave them like this to save time. So this is the structure of our alcohol. Okay. That's the structure of our alcohol. But I think I'm making a mistake. Am I not? 1, 2, 3 plus 2. Yeah, that's fine. Okay, so that's good. So that's what we've got. So that's all we have at the moment. We don't have enough information to know what those others are. At this point, guys, we have what we have. We take it and run with it. Compound B has a general formula. What do you see? It's similar to alkanes, but we just lose 1 hydrogen and then we substitute with X. If that's the case, this is indeed a haloalkane. So we nailed it. That's a general formula for haloalkanes. So you see, as poopy, ulwazi lwethu alusibhayizisi, guys, nakancinci. sozubhaziseke xa unolwazi, but xa ungenalwazi uzawuxelelwa yonke nonsense uyithatha uyifake engqondweni bese uyakhala undikhohlisile. Stupid. Vele izibhanqa zezokukhohliswa mos. Alright, name the homologous series to which compound B belongs. Nice and easy. It's haloalkanes. Halo. Is it halo or is it halo? Yewena uzasiphoxa apha ngothetha isingesi esiqhekekile. Name the type. You see now, name the type of addition. This is a stupid question. Why would you say such a stupid thing? And these people are so stubborn. They persist on this nonsense. Where have they had such a thing? Name the type of addition. What do you mean? This is already the damn type. Heaven. Just say name the addition reaction represented by reaction 1. That's all. That's all. You know. Now, folks, we have a problem. I promise you. We really have a problem now because we did not have enough information. You cannot ask me to name the addition reaction, but of course, okay, you can. Sorry guys, I'm sometimes ridiculous too. If I'm already told this is addition, this is definitely unsaturated. I cannot add to a saturated. So already this is giving me the vibes. Can you see guys, knowledge is power, man. Yabona ba ugese kabi, ugesa kahle kamnandi nje. Balapha njengenqini. Awudulahleke ungaba ulungisa izinja lezilwanyana zasendle. Of course guys, if this is unsaturated, this must be an alkene. Ayikho enye into engaba yiyo. We don't do additions on alkynes. So you know that once you mention addition, the substance to which we are adding, it's an alkene. So this must be a hydrohalogenation, because for us to have a halogen here, we must have added a hydrogen halide. So this is the name. So we can say this is hydrohalogenation. Or is it hydrohalidation? Because it's a hydrogen halide. It's not a halogen that we add, but whatever. Because a halogen, remember, it's the diatomic format of this. If let's say this is bromine, so this is Br2. Br2 is a halogen, but Br minus is a halide. And remember, we added a hydrogen halide. So we should be saying this is a hydrohalidation or hydrogen halidation, not halogenation, whatever. And you see there's lots of misnomers here, talking nonsense, making it a standard. Go away. Anyway, that's what it is, guys. Are we getting one makpa? Naman. Near. You're stingy, man. 7.1.3 says, using the structural formulae, write down a balanced equation for the reactions type 2. Remember, there's a lot to think about. So remember, the structural formulae only applies for an organic compound. Remember what we need to change a haloalkane to an alcohol. It's a substitution reaction. Now, there we need some things for this to take place. We need mild heat, right? Because if there's no heat, it's not possible. Remember, those single bonds are stubborn. They don't want to break. Okay, separate. Yeah, they break in here. They don't want to break. So we need energy to break this. 2, remember, these things are insoluble in water or partially soluble in water. So it has to be soluble for us to be able to work with it. So we need alcohol as a solvent because, you know, most non-polar dissolves non-polar. So we need a bit of ethanol there. Although we're forming alcohol, but we need ethanol as a don't. So always think of reaction conditions for some reactions to take place. Secondly, what do we need, guys? We need a dilute strong base. and a strong base is a metal hydroxide. Right. You know this. So technically we need all of these things. So, well, we're gonna do it. If we've got 5 carbons, it means that haloalkane has 5 carbons too, because it doesn't change. We only exchange the substituents, not the main chain. So this is 1, 2, 3, 4, 5. Now we know the OH replaces the halogen. So now we want the halogen back. What is this halogen? Nobody told us what it is. Hell no. What the hell? We're gonna write X, chemos, because we don't know what this thing is. Wow, this question was interesting, was it not? It's a punisher, this one is doing the things. You see, you end up in trouble, not knowing what to put. I wish they told us though, but then they didn't want to tell us what this thing is. This is the one though. We're gonna add potassium hydroxide. Remember the inorganic reactant, we don't write the structural formula. Do not do it. You don't know the shape of some of these substances. So stop right there. The shape of the organic ones, we assume it in 2D. But even that is different. Those bonds are actually not as straight as you see them. They are not. Then we go over. Okay, masibhale kahle guys, so that sizozibhala zonke. Nansi masibhale kanje. Khona la. Sibeke pha ecupheleni. In the end there. So we're gonna have 1, 2. No. 1, 2, 3, 4, 5. We saw that the OH is now over there. Because we now have an alcohol as a booze. Plus, what else? So if we replace this thing, we're going to have a potassium halide. Yeah. A potassium halide, and you know KCl is a salt. If that was chlorine. Potassium chloride is a salt, or sodium chloride is a salt. Say perhaps we used sodium hydroxide. Then we're going to have NaCl, which is a salt. So maybe. Why not use sodium? Singamsebenzisa masithi na NaOH kodwa no akho sidingo man. Yes. Dimosha. Sendicinge ngale ndlela endicinge ngayo. So KOH qha. Ndifuna lo K acace kodwa ingxaki yam ndibona uK wami uba usnacks. Ufana no X. So whatever guys, this is the one. So folks, apha ebridgini sitheni sisebenzisa heat or mild. And we state that this is dilute. Sometimes you put a subscript ka D phaya. Ochaza ukuthi si dilutile le. Because xa ikhe yaba strong ibe concentrase. You put a D there to suggest ukuthi si dilute. If I can go. So that's the thing guys. So inje ngokuba inje ayikho enye into ongayenza futhi. I don't remember. Upper we can even say with ethanol as a solvent. Okay. Koji ethanol sibhala kanjani? Etho as solvent. Just so that we can treat our haloalkane. Otherwise, if it doesn't dissolve, the reaction ayizokwenzeka qonda. Yeah, we must use it. So ungafaka kwasani ke guys phaya kula bridge ngoba ezazinto eziya, they're not necessarily taking part, but they are just making things happen. Because this mild heat does two things. breaks this OH and K, it also breaks one of these hydrogens. Of course, the halogen is the one that doesn't hold on as much as the others. If you can ask me a question, why? Why exactly? Why does the halogen break off easily than the hydrogen? Because if we talk electronegativity here, let's see. Let us see. What is the electronegativity difference between the carbon and the hydrogen and the neighbors, the halogens or the halides? Think about these things. Now let's see what's the difference. The electronegativity there is 2,5. So this is 2,5 for the carbon. And then let's see, for that one it's 4,0. Let's just say 4, 2, 2, 2, 2. At best it's 2. Yeah, but up to 4. I mean. Masiziyeke ndifuna kodwa sifocus kwi-electronegativities. Electronegativity carbon is 2,5. But do you see these ones range from 2,5 to 2,8, 3 and more, right? And then let's look at the hydrogens one. I don't know, we're gonna see if there's some logic to this. Can you see it's 2,1? So which one would have the greatest difference? Yeah, you see, most 2,5 minus 2,1 is what? 2 and 2 is out. It's going to be 0,4. Ne? I'm teaching you things now, guys, that you can use to make sense of some situations. Of course, this is now an academic guess, I believe. It's not really true because I don't know. Yeah, it's 0,4. But do you realize when we take the difference between the carbon and the halides, of course, we take the one that has the biggest. It's either 4 minus 2,5, which is going to be, let's see, 2,5 minus 4, or 4, that one. This is 1,5. 1,5. At most, this is the biggest difference we can get. But let's see, what about the chlorines and the others? Remember, you have never really seen us using the fluorine, and this makes sense. This is when this is the fluorine, which we hardly see in your syllabus, hey? Let's take the usual ones, the chlorines, the bromines, and the iodines. So the smallest difference, or the biggest difference, is when we've got 2,5. So we've got 2,5 minus 2,5, which is 0. Can you see the smallest difference is like that, and then the biggest difference is when we've got 3 minus 2,5, which is 0,5, right? Now this compared to 0,4, the question is the electronegativity difference. Hey, you're saying betile heke manje. You see, the electronegativity difference is comparable. So now, if at all there's anyone who should hang on, is the halogens. Hydrogen should give up easily, but hydrogen can give away. I think it's only because hydrogen, the reason why hydrogen doesn't care is because hydrogen is not interested in attracting electrons. Can you see? The electronegativity difference here would tell us that we have the greatest electronegativity difference between carbon and the halogens. Meaning, when that bond is under pressure, the halogen says, well, I'm taking what's mine and going away, because carbon is occupied with either hydrogens. Maybe it's not allowed to just let go. But hydrogen doesn't care whether you are busy, entangled or not. It's like that guy who, when the girl cheats, he just doesn't fight, he just walks away. He doesn't care because, you know what, he doesn't invest in that person. But you see, the fools that invest, They always cry and want to fight and want to damage things and damage their reputations and their lives. Anyway, guys, I don't know. So I think the halogen always under threat. It's like, well, I'm taking what's mine and I'm going. Whereas hydrogen can say, well, I can leave. You can even take what's mine. I don't care, I suppose. Anyway, guys, I was just trying to find some logic, but it's not really strong. It's not convincing what I'm saying. But try to find out. These are some of the things you should do as you study your subject. You try to find out why. Because experimentally we see this, but why? Is there any logic to this? Then we start manipulating things, and using other substances to see exactly what's the trend. Then from that, we can make a conclusion that, okay, maybe this is related to electronegativity. The ones that are most electronegative, they tend to walk away as soon as the bond with other substances is under threat, whereas the less electronegative ones don't give a damn. Okay, I don't know. You decide. You go and find out. So find out why does the halogen or the halide, you can just say halogen carelessly, but it's technically the halide ion. Why does the halogen, or you can say the halide ion, break away easily than hydrogen from the carbon chain? Go and ask your teachers this question. Remember, siyafunda la, guys, and ukufunda, you have to get behind things. Can't just take things on face value. Otherwise, we won't know what we're doing, and that means we'll be useless when answers are needed. See now, people needed to find solutions during the COVID saga, although we have questions about it. I have questions, but I'm not going to voice them out because I know it was all nonsense after all. But let's leave that as it is. But let's say now, look, people were looking at the wrong solutions because, look, they looked at a vaccine. I'm just going to demonstrate to you that people who don't understand how a vaccine works, they thought a vaccine is going to stop a spread of a new disease. It cannot, it won't, never will, okay? So, just stop it. Just stop it. Only preformed antibodies can do this. If, for example, you want to neutralize a virus, you want to contain its molecules and substances that it causes the body to form, which is the mechanism in which the damage is caused in the body. So you can only bring in preformed antibodies against this. That means you have to produce them some way. Then bring them and inject them into the body, because then they have an affinity to the substances or the molecules of the virus to contain it. But you cannot tell me you're going to give a vaccine which has to first induce an immune response, then later on form memory cells, which then will start dealing with the virus. I mean, come on, someone is dead by that time, because damage is being done while you're busy wasting time here. All right? Because the question is, how long does it take to form memory cells? Nobody can tell you. Because also no one knows for sure how many attacks of the same infection must you have before you can mount a good long-term immunity against it. We have not found information about that. You can't just get one, I suppose, I believe. You can't just get one encounter with a virus or an infection, a bacterial infection. If this is the case, why do people come to the hospital for the same infections? They had a flu because of a gram-positive streptococcus, right? We treat it. That means they've developed memory cells, but all of a sudden in the future, they get infection again. You get it? Why? Why? So this already tells you it takes more than one encounter, I suppose. Even that encounter, if it's not a regular encounter, you lose that ability to fight off these infections, I believe. Of course, it's still a belief for now. I'm still going to get into the lab, folks, and bring you all these answers. At the moment, I'm trying to generate money because the state is useless. It never funds what makes it look good. So we have to do it privately so that we can charge the damn state millions. So I can be stinking rich one day. That's just dreaming. It's never going to happen. Anyway, guys, what I'm trying to say, understand why. Why is our friend so easily removed from his or her position, while the hydrogens are as stubborn as ever? Why are they stubborn also? Because we need to know, why are the damn hydrogens so stubborn? Why are those bonds strong? Okay, all right, okay. Now let me tell you something. You see, these molecules, if you look at their molar masses, this is another way of looking at this. Hydrogen has the smallest molar mass compared to these other halogens except fluorine, right? All the others have a bigger molar mass than carbon. Now, this may be related to that carbons bond more strongly with molecules of perhaps a smaller molar mass and appreciably of a certain higher electronegativity of some sort. Maybe the difference must be significant, but not just electronegativity. The molecule has to be small in size, or the atom. Hydrogen is a small atom, but chlorine has a bigger atom than the hydrogen atom. And can you see, this is why perhaps it gives up easily, because this one is heavy, man. It's not easy to hold heavy things under pressure. You can only hold a small thing under pressure, isn't it? If, for example, your friend says, Dula, I have nothing against this Dula, guys. Vele namba yandiqhenza bathi ndilecala babendibiza ukuthi ndiyenye type yabantu abakhona apha eMzantsi ngoba ndandineshrapa vele ndisenaso ishrapa nangoku. Well, andisenaso saphela. By the way, ngelo xesha ndandiseneshrapa ke babendichwenza masithiwa ndibhityile ngaphethulwa ngumoya ngandagwinya inaliti. Yayibona loo nto, wonke umuntu uyachwenzwa wethu. It just depends at the time. When you are younger, you know, a bigger size is more appealing because even parents go like, yeah, that one is well fed. But when you become older, a bit of a big size is an issue because it says, yay, you ain't gonna be able to do certain other things that we are doing as the lightweights. You get it? So essentially, you know that if my friend is a lightweight, if kuvela into esijarhayo ndingamthatha ndimbeke egxeni ndibaleke naye, right? But I can't do that emntwini osindayo. I let go, baba. Omnye nomnye xoxo nexoxo liyazixumela. So think about it that way, that okay, science ifana ne-reality of life, isn't it? So this would make sense that, okay, the halogen gives up because mostly they have a higher molar mass than that of carbon. So carbon lets go, says, thank you, friend. I can't carry you under pressure, okay? So if I'm pressured, you are gone. Because you're heavy. So see for yourself where you go. Right? Right. I guess within the same class buffet too, and the same exploration of answering a question, we somewhat get something sensible out of it. And I think you would see that the trend tends to follow this pattern. Because you will see that if, for example, you've got a multi-halogen or halide sort of molecule, say you've got bromine, you've got chlorine, you've got iodine, you will see that experimentally, if you put that molecule under pressure, you'll tend to see the iodine more replaced than the others because they are not as heavy. You get it? Yeah, man. Yabona ngoku siformulatile le nto leni, kodwa ke guys bubuxoki bodwa obu but obumnandi, yabona ndixoka kamnandi ngalo mzuzu. So we get a mark here, ne? Yeah, we get a mark there. Yeah, we get a mark for the things, guys, the things. Byproduct, reactant. Maybe the reaction conditions, we should be considering them for the 5th mark, technically speaking, but they are not much of a big deal at this point in time, but do keep them in mind. Eish guys, nthetha kakhulu ne? Yeah man, why not? Why not? Let's do 7.2. Hey, I like these EC papers though, guys. They make you talk, like the way they ask questions. They actually help you to have the best revision you can have over topics, because you will see that these questions are reasonable, but somewhat technical. It's not just unnecessary strain where there's a narrow view in the topic. So this one takes everything into consideration. So well done to these examiners. Please guys, don't drop the ball, keep it, because we want our students now to start rising, but they need to take themselves more seriously. We're gonna make them get there. You see, KZN was sitting down and playing hide and seek in the previous years. Here it is now, we pushed it. You may not see our contributions, guys, because we are underground cables, but trust me, that improvement is because of the likes of us, the YouTubers. Without YouTube, they would not have made it up. Believe me, even the Free State, they would not. Even Gauteng, they would not. Western Cape, they would not. And you can see the trends. How often do you see a YouTuber doing a question paper from the Western Cape? Not so often. Not so often. So there's a tendency for those guys to ignore the work that is done by YouTubers because they are doing papers from other provinces and they don't succeed as a result. In general, it's only a few who are focused who make it. I mean, the Western Cape used to be #1. It's no longer. In fact, it's even forgotten as a contender for #1. Yeah, EC has always been somewhere in the mix. It's always either in the middle or it's at the end. But if you look at it though, wherever you find it, it's a true reflection of what is happening. It's not just, this disproportionate analysis you would find with other provinces and all. Because it's either you passed in the EC or you failed. You were never somewhere in between. If you make it, we know that you represent that pass that you have. If you didn't, you just don't know enough, and that's it. You cannot say the same for other provinces because there's a lot of spoon feeding happening in those provinces. We know it, and as a result, students pose as people with knowledge when they in fact don't have it. And this is what we are trying to destroy with these videos that we make, me and my colleagues on YouTube, because we're trying to make sure that as you make it, provided you have all of this spoon feeding, let's put some perspective to that spoon feeding so that you don't take it for granted, so that at least we don't just produce numbers of passes but quality passes at the same time. Anyway guys, this is all criticism that is perhaps intended, or at least that is meant to be constructive. But I know I may fail to achieve that, which is not a problem. I'm only human, but that's not an excuse for spewing garbage, which I probably did. No, you decide. Whatever you choose, just know it's not that deep. Anyway, right. 7.2 tells us that organic reagent H2 is used in reaction 3. So this is hydrogenation. Do you see this thing, guys? It was asked in the MCQs. We saw it in the naming. Now it's here again. Dang. I told you, MCQs are an eye into the brain, which is the structured questions. Write down one reaction condition needed for reaction 3. We know that platinum should be the catalyst. Sorry, we can say PT as a catalyst. Sometimes they use nickel. Nickel, Ni, can be used as a catalyst. There's 3 of them. I forgot the other one. It's platinum, nickel, or what is the other one, guys? But that's the one. That's the one. We need that. Do we need heat? I'm not too sure, but I think so. Because hydrogen, again, remember, it's a diatomic molecule, so we need to break it into, hydrogen ions so that it becomes more reactive. It's less reactive as, a diatomic molecule because it doesn't want anything, but we need to make it want something, right? Right. So I think heat might be, yeah. But if we catalyze, it means we can use mild heat, maybe. But here we were asked for only one condition, so we can mention one. Because, using a catalyst, it means we would have needed a lot of heat. So by doing a catalytic reaction, it means we would need less than we would if at all we did not catalyze. Okay, now it's either one or the other, but not both. You're not going to write both. Question said 1. 7.2.2. I can send it here, Makar. Maybe I'm hungry. It says now, using molecular formulae or formula, but should be formulae. It was just one formula. Write down a balanced equation for the complete combustion of compound D. Now, we know very well that this is an alkane. It's a 5-carbon alkane. It's a pentane. Right? Because if there's 5 carbons, remember, only eliminate substituents. The parent chain remains. So this one is a 5C carbon. 1, 2, 3, 4, 5. Oops. Those are hydrogens. So you know the general formula, CnH2n plus 2. So guys, take advantage of these things instead of going and count physically how many hydrogens there are. Use the things, man. Use the things. So this is a 5 carbon. So this is C5H2. That would be 10 plus 2. That's 12, right? Yeah. Real. Plus oxygen should give us carbon dioxide. Plus water vapor, because they are shisala. But if we contain all the substances, then it becomes water, because it will condense on the walls and become water droplets, which become water liquid. Thank you very much, comrades. It is steam when it is open, because the steam is going to go into the atmosphere. Even in the atmosphere, the higher it goes, the colder it becomes, and then these condense into small droplets, which combine into some cloudy-ish hazes, which become water. Water cycle in nature. Oh, I studied in standard 3, guys, which you guys call it grade 5 now. All of these things came from way back, huh? The knowledge is power. All right. So we expect 5 carbons here. And then we expect 6 hydrogens. Now let's see. 5 carbons balanced, 12 hydrogens, yeah. Now we've got a problem of 10 oxygens plus 6, so they are 16. Now there's just 2 here, so we can just put 8. 8 you. That's clar now. You see. Nakuperera makiniso. First, the molecular formula. And yeah, bafethi yabona ngokuyan biases. Let's just say left hand side, right hand side, and then the balancing coefficients, whatever you call it. Igqityiwe kodwa. Qwaba. Now draw a sketch graph of a potential energy versus time of the reaction of 7,220. Oh guys, do you see now reaction rates and stuff? We know that these are highly exothermic reactions. Although we start them, they don't start on their own, but once started, they pretty much do it by themselves. So we end up with the energy of the reaction of the reactants. Yeah, stuff like swa. Stuff like swa. I'm not happy with this one. Yeah. Imnandi. Izone. This is the one. It's an exothermic type of a reaction. So we know that this is potential energy. This is kilojoules per mole. Right? You know almost this thing. And then this one is going to be the duration of reaction. Sometimes we call it the reaction coordinate. Whatever suits your taste. Whatever suits your taste. Now, what do we have as the reaction? We've got the reactants, right? So this is C5H12 plus O2. Here we don't care about the balancing coefficient, and then here we've got carbon dioxide plus water. Those are the products. At this point we don't care about, the stoichiometric relationship. I think this is it, guys. As long as the other one is higher than the other, we don't have specific values. As you can see, it's just 2 marks, shape of this thing and the difference in the energies. And LS. But remember, guys, if you draw any graph, it must have a label. It must have a label. So refrain from just do nicely. Just say this is a potential energy versus time. What did they say again? Versus time for reaction graph. Of course, you can even specify now in a space. But akufunekanga float nje graph. Nesiyazi ba uthetha ngantoni, yaqonda. Now guys, it's done. Yabona sigqibile ke ngoku. So we take our 12 marks. As you can see, these 12 marks was a bit of a rough ride compared to the other organic chemistry reactions, because here we needed to think. We needed to come up with things that are hidden, and of course use our knowledge. And I tried to stretch your imagination a bit by telling you, why does the halogen fall off? Because usually the ones we use as substituents are much heavier than the carbon, and hydrogen is lighter compared to them, and yet the electronegativity, as we saw, it's not so different. It's appreciably the same. So obviously, on equal footing on certain aspects, we don't want more weight. We tend to lose it, or we tend to give up on the heavy things. Even as language doesn't be less cheese, like you throw them away and you run on your own feet. So that's just life, guys. So nalapha, these molecules are like you and I. If you're causing a reaction to take place, you're putting them under pressure, Baba. Now under pressure, they will carry what is light and drop what is heavy. Anyway, guys, I hope you enjoyed the video, and of course, our total here is 100 marks. Please, guys, double check me. I may have committed some errors along the way. Most when I'm relaxed, I tend to do this. But as I said, don't focus on me being correct. Focus on learning, because I can tell you for free that the direction that I gave for each situation is not going to put you far off course. All right. Key is to stay on course. Then you finesse everything, because it's your responsibility, it's not mine. At least my duty is to at least show you the way. The fathers of human psychology, behaviorism, B.F. Skinner, said, we learn by observation. So this is why I try to show you. But you finesse things yourself. And my also important thing to reinforce that learning, as was described by Sigmund Freud in his theory of operant conditioning. You see, that can be maintained with reinforcements, positive reinforcements. Of course, if you do well, I congratulate you. I commend you, give you a pat in the back so that you can maintain the eagerness to do the right thing. But of course, if you're doing silly things, I need to punish those things, which is negative reinforcement. Then you stop the nonsense, you pick up the good things. And as B.F. Skinner said, give me 5 kids, I can make them into anything. One a doctor, the other a lawyer, the other a criminal, and you name them. He was right. Because those things, they can learn by observation, because if you subject them to environments that promote such behaviors, they will definitely follow suit. This is why I'm against these stupid movies or soapies that they create in this country, because they copied the USA so much. I have nothing against the US, guys. Don't get me wrong. I don't have any issues with that place. But if you look, most of the violent, society-breaking behaviors we see on their soapies or reality TV or whatever, music, you see the music videos, the dances you see there by women are not good. And as a result, we made it look like this is how it should be. And look at our people. Unfortunately, they are suffering in here because it's not the other side. You see, maybe it's safe to do those things in the US. Everybody understands them. We don't. So as a result, we take advantage of those situations. And when bad things happen, we cry as if we didn't know any better. Human rights will fool you into believing, I have a right, you don't have a right. Yeah, it's okay. I don't have a right to do things to you that you don't deserve, but, well, I just did them. So what? If I did it, then what? Me not having a right, will it stop me not doing it? No, it won't. It's only consequences of what I have done that may motivate stoppage. But now, do we see any actions against such behaviors? No. Instead, we are promoting more of these behaviors that lead to these disasters, but no consequences. Then we can't stop these things. But remember, guys, we cannot only focus on consequences. Prevention is better than cure. Remember, if your kidney is already damaged, even if I can save it with medication, it will never function the same way it used to before. So it's already altered. So just remember that. To think of treatment against prevention, you will remain with scars that may impact the quality of life that you live going forward. Goodbye. I'll see you next time. Ciao.